Today we are gonna talk about the plumbing services. I mean all about the complete plumbing over here, and we'll be dealing with this plumbing in the terms of the mechanical electrical plumbing, which is also known as the building services. So I'm talking about a part of building services that is nothing but I'm talking about one service among a building service that is only about the plumbing. So let's move on with this. I do have some content with me. We'll be dealing in this manner. So first of all, just let me get into this, and if you see over here, today we'll be talking about the first chapter in this manner. Okay, so all you can see over here, we know this, that plumbing is divided into two parts. First is the water supply or the water system, and the second is the drainage system. So we all are over here to just discuss about some basics all about the plumbing. So let's proceed in this manner. Very first is what the introduction. So you people know this, what is all about the interaction over here. Let's discuss in this manner. So as I said, we are dealing in the building service, that is nothing but a mechanical, electrical and plumbing, which is also known as M.E.P. It's also called as the building services. So I'm dealing with one service as of now, that is nothing but the plumbing service. Okay, so let's deal up with this. So as you people know this is mechanical, electrical, plumbing and services is a significant component of the construction supply chain. As you people know this, now this is given a huge priority because M.E.P is the biggest service among the service in the building services. So that's why this is given a huge amount of priority, because it's among these services, among all building services, this is a biggest service over here. And the moment it is biggest service, it is what the pricing also a bit higher when compared with the different services. Comparing to the different services, that means we do have a number of services, and if you can see over here, there rather than this M.E.P, we do have electrical, HVAC and plumbing and firefighting. These all services nothing but M.E.P services. Moreover, we do have elevators, service, solar, gas, security and BMS. Now these are all services also included in a project. Okay, but as I said, among all, this is given a huge priority. So, and we know this, not only this M.E.P services will be having a complete plumbing, I mean this not only having a complete kind of building over here, because this is inside a building, we do have is this services which is for human comfort and all this. Okay, for the facility of the living style, you can say in this manner. So these all service or more services will be combining, and it will be having when creating a one building. It might be commercial or residential for a better way of living. So let's move on, as we are here just to discuss about the plumbing. So first of all, let's see what is plumbing over here. In general, I'll say plumbing is nothing but it's a flow of water in a through piping, I say, or I can say flow of water or any fluid through piping. This is in general, but as per if you see in regards of this plumbing, what we are dealing about in this over here. So let me tell you about this. Now plumbing is a system of piping, an apparatus and fixture for water distribution and waste disposal within a building. So that means it's a set of piping, you can say, or it's a system of piping that has been attached to apparatus and fixture for the water distribution and waste disposal within a building. That means at the same time it needs water for some fixtures, at the same time the water should be drained from that fixtures units over here within a building. So it's basically a combined, a kind of system, you can say. It's not only something which is only water supply, but what about the drainage? And so basically when you combine all the services, it's a system of piping, because it's a system over here. So this is a plumbing, or else in short you can say it's nothing but a set of pipes, or else you can say flow of water or any or the fluid through the piping is nothing but a plumbing. Now let's talk about what is a plumbing system. Now first of all, we are dealing mostly with the residential projects over here. So I'll just give a definition in regards of the residential project. A residential plumbing system is a network of supply water supply pipes, drain pipes and vent pipes. So there are three things over here in the project. Not only the water supply, I need drain at the same time to drain the water, I mean the waste water or the soil water, whatever it might be, whatever the drain is. And for sure I need vent pipes also, just to vent or to exhaust the gases out from the project. Okay, so these are the three things over here, which is a network in a plumbing system, you can say, which has a supply of water, the drain and the vents. So this is a plumbing system. Now As I said you previously, now plumbing is divided into two parts. First is water supply and second is drainage. Now further, this is classified into 5 piping networks under plumbing. First is over here water supply, and under water supply you'll be getting is hot water and cold water. And second, in this drainage you'll be getting under drainage there are 3 kind of systems over here, that is wastewater, soil and surface water. Now we'll see what is wastewater, soil and surface water. Now cold water is nothing but a water which is being served or which is being supplied from the municipal directly to the project. Now hot water is something that I get a municipal water from the municipal and it travels along through the piping and it goes to the heater where the water gets heated up and the water is being again served to the concerned project or to the concerned service. That is hot water, nothing but this is hot water when being served an equipment, it's been heated up. So that's a heater over here. And in the drainage, as I said, waste, soil and surface. Now wastewater is something the water coming out from what, except you can say WC and urinals, it's a wastewater, because soil water or a soil pipe is something which is carrying out the drain or which is carrying out the waste from the WC and urinals. So this is a soil pipe you can say, or a soil water, nothing but you can say in short carrying out waste from the WCs and urinals. Except this is wastewater. Now you can consider this wastewater in terms of the from the kitchen sinks, from the showers, okay, and these all kind of things you can consider in terms of wastewater. And surface water is something you can now consider this in terms of a roof system, I mean the roof drain. So that means in case of rain and all this, the water collected at the surface of the roof, okay, it needs to be drained out. So this is the thing which we need to have. So this is surface water, nothing but the roof water. We need to drain these things over here in the drainage system. And this is water supply, cold and hot water things over here. This is just a picture of how exactly plumbing. So you can see these are called as fixtures, like we are seeing this is laboratory, this is WC, and this is a systematic arrangement. Not only demands for the flush, at the same time it demands the drain water. So to drain, this is you can say as a soil pipe over here, and this pipe which is connected to the laboratory is nothing but the wastewater. And there are some fittings over here. Now this is called as a trap over here. There are some more fittings. Now as you can see, here is elbow, and here is T. So this is all you can combinedly you can say it's a system for the piping and in terms of plumbing. So this is just an idea how this things goes on and all this. So there are some standard societies in the terms of plumbing. So very first and commonly known as what IPC, that is nothing but International Plumbing Codes. Now International Plumbing Codes is generally being accepted commonly because as it is international, so it has been globally accepted throughout the world. That's why it is International Plumbing Codes. Now UPC again is a code. Generally you will be seeing this in Gulf countries. And British Standard, UK, like example, if you are working in UK and all this, so you'll be having these standards in the UK because they'll be having their own codes, okay. And DEWA, this is Dubai Electricity and Water Authority, this is from what, UAE. NBC in India, IPA in India, Association Qatar, Kharama in Qatar. Now let us talk about the standard societies. What are the needs of the standard societies? But before this, what does this society does? First of all, this standard societies, nothing but this what you're seeing over here, they generate codes over here. Code is nothing but you can say a value, and we get this value based on the experiences of the research and development team, where they have researching on some XYZ region. Now you can say now IPC, they have been researching on the entire world, and there'll be some codes. For example, as we know this, if I'm working in any project, if I'm near the seashore, I'll be getting, okay, I could not go for a GI kind of material for the piping. I need to go with a plastic category or stainless steel, because I got to know this as per my information or as per my knowledge that it could not be used over here, because there are chances of what, humidity is very high over there, so chances of corrosion is very quick and rapid. So where did I get this values, or where did I get this knowledge from? From some codes or societies, as you can see over here. So this is IPC. They gives me a value. For example, I can say I'll get a ready-made value, not only about the materials. I'll be getting a ready-made value with reference, like example, this WC is demands how much of water per flush, and how much of pressure it requires, how much amount of water with respect to all the fixtures. Same likewise in UPC and British standards, they'll be saying these kind of codes, like example, not only to the fixtures, with the respect to the people also. Like example, if you talk about in this UPC and IPC, I'll be getting the minimum number of the fixtures, and I get to know what fixture demands how much amount of water in terms of GPM or whatever the unit is, and not only the GPM, it demands some amount of with pressure also. So both the things will be getting in this detail in the standard societies over here. So let's see over here one by one. But let me tell you, like I said, UPC and British standards, if you're working for a company which is in UK based, okay, so they'll be following this standards, because this, they get the values based on their community in that region. They have been specialized and they have done some research and they got some values, so that I get a ready-made value, so that I can use this value and I can proceed up with the calculation part or the selection of the pipes and all this, I mean the diameters and all this. So based on these things, I'll be getting help. And not only over this, because when I submit a design over here, I need to give a reference, okay, that I do have taken this units, or I do have taken this values from XYZ standard that is listed below over here, you can see. So I need to submit this to that. I have taken this values from this standards and all this. But what is the need over here? Let's see. What is the need of this plumbing codes? As I just now said, now plumbing code is a code that provides regulations for the design, installation and inspection of building for plumbing and sanitary system. What we have discussed just now, it provides some regulations with respect to the design and installation, how the things should be installed, and inspection of the building for plumbing and sanitary system, the same kind of thing. So that means you'll be getting help in terms of the designing purpose and in the installation purpose by using this international plumbing codes or any code from the plumbing. Okay, now what is the need of this? This is what is plumbing code. What is the need of this codes? Now let me tell you, plumbing design based on a probability, except special cases like ablution tap, residential school. Therefore, to design plumbing, standards and codes are required. Now, as I just now said, always remember, the moment I said plumbing and this M.E.P services, the moment I said plumbing, you need to make sure that plumbing is maximum casesly designed on the probability. Now what do you mean by probability? Probability is nothing but the chances. Like I'll say you, it is based on the chances only, but except special cases, and that special cases I can say as a peak demand. Okay, and what are this peak demand? That is ablution tap and residential schools over here. Now let me elaborate this a bit more for you people. The plumbing design is based on the probability. Now what do you mean by probability? I just now said probability is nothing but just to the chances. For example, everyone just consider that I do have a bathroom, okay, in one project, and in that bathroom I got to know there is one WC, one shower, okay, and one lavatory and one water bidder. So these are four fixtures over there in one bathroom. So now do you people think this that all four fixtures will be utilized or is being used at the same time? For sure no, because one person or maximum of two persons, one person only, they might be using this, isn't it? Per person, maximum one person or two person will be using. So there is a very less chances that all the fixtures might be getting used at the same time. So it's very difficult to proceed up with this for the four fixtures designing of the pipe. So that's why we do the designing of the plumbing with respect to the probability basis. That means I'll be getting this probability value or the probability unit from the the codes over here, what we just now discussed about, and those fixturing require water must be, as you can see over here. But special cases, now what do you mean by special cases? Now special cases like ablution taps, now it's talking about the ablution taps, and one more is talking about the residential school. Now, ablution tap and residential school, it's been clearly mentioned, it's a special case. Now, why it's special? Because it is based on the peak demand. That means we know this ablution tap, where worship area, we know this. For example, we do have a prayer at specific time. So what we have before the prayer, everyone comes over there, perform ablution over there. So we know this, the number of taps in that ablution area is maximum be used for the maximum time. In this limited amount of time, there are chances maximally that all the taps will be working at the same time. Likewise with the residential school, like the kids or the students stay over there in the residential school. When they are done with the school, they go to the residence, which is again in the school premises. So what they do is, when the moment again they are back to school the next day, they'll be getting up early in the morning like 5 or 6, and they'll be doing their activities daily. So what happens over there, there are again chances that all the showers or all the WCs at the same time will be using for a specific amount of time. But it's not about the time, it's about what I need to design in such a way that if at all whatever the fixtures in that area, I need to consider that all will be getting used at the same time. So this is a peak demand. But previously, what I know this, among as a general, as I said, a bathroom 4 fixtures, there are very less chances that I might get that all the 4 fixtures will be working at the same time, isn't it? So therefore I need to check that what kind of project am I dealing with. If I'm dealing with a project which is generally a residential project or a commercial project, I need to recheck, or I need to check with it, okay, whether I'm dealing with a residential or commercial project. If you're dealing with such kind of projects like ablution area and all this, then you could not proceed in a probability basis. Then you need to check as per the project, you need to think, and you need to proceed for the design. Okay, so therefore to design to plumbing, standards and codes are required. That means for the designing purpose, I need this codes. If I don't have this kind of codes, then it will be difficult for me to proceed out with. Okay, so now next is what, where a building contains plumbing fixtures, those fixtures water must be provided with an adequate supply of water for proper operation. What does this mean? This means what? Where a building contains plumbing fixtures. Now, as I said just now, plumbing fixture is something, let's discuss plumbing fixture in general. As of now, to avoid confusion, let me say you a plumbing fixture is nothing but a kind of, this all those fixtures, like as I can say, WC is a fixture, lavatory is a fixture, okay, shower is a fixture, bathtub is a fixture. These are all plumbing fixtures. Okay, and I got to know that these fixtures will be demanding some amount of water, and that what amount of water? An adequate supply of water. That means a sufficient amount of water supply for their proper operation. Now let me relate this. For example, if I'm having a lavatory is nothing but a wash basin. So lavatory demands a very less amount of water when compared with a shower. So the difference of the water supply to this and this would be differentiating, because as this is for the different service, this is a shower is for having bath, and this is for just for cleaning your lavatory, I can say, just for your hand wash and all this. So limited amount of water over there. Here the amount of water or the water supply is different. If I don't provide this amount of water, what they are adequate supply of, so what happens over there? The proper functioning of the fixture will not be done, okay, and it will not serve the purpose. So therefore, to have these things, to perform all the fixtures working in a proper manner, I need to supply an adequate supply of water. Don't worry, we'll be saying this as per the code. So codes will be helping us how and what should be the adequate supply of water for each and every fixture is being given. We'll be seeing this. Okay, and moreover, apart from this, if you see here, the number of required plumbing fixtures is specified by this code and is based upon the anticipated maximum number of occupants for the building. And the type is what? And the type of building occupancy. That means one should know, first of all, if the plumbing fixtures, for example, if there is no plumbing fixtures given from an architect, So what do you mean by this? So do not get confused that if it's not being given from an architect, what you need to do is you need to first of all read the project. If it's not given the fixtures over there, need not worry, we can have this by using the code. Okay, the minimum required fixtures, I can do this. I'll be showing you. But how you can do this is based upon, if you see over here, the anticipated maximum number of occupants. First of all, you need to know how many number of occupants is there in the project or in that building. Now it might be differing from something, like it might be commercial, residential, whatever it might be. First of all, you need to know the number of occupants in the building and the type of the building occupancy. Again, what do you mean by this type of the building occupancy? It is residential, then we do have a huge number of things in the residential. If it's commercial, we do have subcategories in the commercial. The same thing what it's talking about. So if I have this much of information, I can find out the minimum number of plumbing fixtures in the any kind of project if I know the maximum number of occupants over here. Now this code provides prescriptive criteria for the pipe sizing systems connected to those fixtures. While having this, as per the fixtures and all this, one can find out the prescriptive criteria for the pipe sizing. That is nothing but improbable, as you can say, or you can say a peak demand as per the project now. But the main gist over here, I can size a pipe size based on the fixtures. Okay, it might be probability as per, it might be as per the peak demand. Is again, this both depends on what? This both depends on the project. Okay, through the use of the code, approved materials and the installation requirements specified in this code, plumbing system will perform to their intended life of the building. Now what do you mean by this? Through the use of this code, approved materials and the installation. As I said, we know this in some services, like if I'm having this depends, the material depends on the type of the project. For example, if you're dealing with commercial or if you're dealing with a residential project, we need to check very importantly in this area or for this project. For example, if it's like an residential project and I'm using for the water supply system, so the material would be, I need to check that this material is being approved. That means approved in a sense that is not harmful for the human, so I can make use of the transferring of the water in this manner. For example, it might be for the drain side also. Just talking about why approvals, because we got to know this. Okay, when such kind of thing is being passed, like this amount of liquid or this amount of fluid or this kind of fluid or liquid, whatever it might be, it's been passing, so it should not get contact with the material. So that means I can say in short that I got to select a material which is safe for human beings as I'm dealing with plumbing thing, and mostly will be what fluid we do use over here, mostly for the water supply, isn't it? It might be for the water supply for the drinking purpose, or it might be for the water supply towards the circulating water to the complete the project, isn't it? So I need to know. Likewise, what I need to know, for example, if I am circulating a hot water throughout the complete project, and I need to know this, that it could not be because every pipe has some kind of pressure bearing. I need to know, okay, this much of pressure it can bear and this much of temperature it can bear. If I'm exceeding more than that, that material could not. So I need to know all these things. So where I'll be getting this approved material, so they'll be giving us that this should be done from over here, this kind of material should be used in this kind of place and here and all this, and how the installation should be done in respect of the project. Okay, so now these are the things over here what we have discussed. As I just now said, we'll be seeing this, the containing fixtures, plumbing, and I said now, first of all, an adequate water supply. So I'll be showing you something I do have is, first of all, this one code over here, that is nothing but International Plumbing Code. It's a one book with me. So let me just say you, first of all, in the chapter 6, if you go in this, and the table number is chapter number 6. Okay, so as you can see over here, this is chapter number 6 and page number, as I said, 55 online. So this you see over here, this is table number 604.3, the water distribution system design criteria. First of all, I said you that what we have read the theory over here. If you see, Here are the fixtures and here are the flow rates of the fixture in the terms of GPM, and this is the pressure required, because both the things is important. If I do have the flow but not the pressure, it will not serve the purpose. If I do have pressure but not the flow rate or the Q, it's again not worth it. So both the things are important. So now let's talk about something. Let's see about the shower over here. So if you talk about a shower demands 3 gallons per hour, that is GPM. Sorry, GPM stands for gallons per minute. I said GPH, sorry about that. This is shower. So this demands GPM, that is gallons per minute. That means it should be supplied with 3 gallons of water per minute and with a pressure of required 8 psi. Okay, so it's not only this, all the fixtures you can see over here. This is urinal with valve. It demands 12 GPM with 25 psi. Now if you see laundry tray, lavatory demands 2 GPM with 8 psi. So in this manner one can find out how much. If I don't provide this, he was saying some adequate amount of water supply. If I don't provide this adequate amount of water supply, for example, if I'm going with 2 GPM, it will not gonna work, isn't it? So that's what for sure what we need to do is we need to proceed up. We need to check that we are giving a sufficient amount of water so that it can work in a proper manner with this much of pressure. So both the things has been mandatory, flow and pressure. Okay, I mean the Q and the pressure. So this one thing is been completed. What is we are saying with adequate water supply of proper operation. Now there was something second point what they are saying, the number of plumbing fixtures can be find out in this manner. So this is on the page number 40 and the table number is 403.1. This is minimum number of fixtures, minimum number of required plumbing fixtures. Now if you see over here, there are classification, occupancy, description, and these are the minimum number of fixtures what you are seeing over here. This is water closets, this is lavatories, bathtubs and drinking fountain. So this is basic need: WC, lavatories, bathtub, drinking fountain and others. Now for example, if you see over here, in this WCs we do have 2 sections, male and female, lavatory 2 sections, male and female, bathtub single and drinking fountain single. Now let's take for example, if they are saying that your project occupancy or the classification is like educational, you can say, for example, you're dealing with the educational project. Now you can say educational refers to any college or any institute and all this. So it's over here. So what do you mean by this 1 per 50? What do you mean by this? Here this means is nothing but I do have is what? It's nothing male and female. Here is saying this in education I need 1 per 50. That means in the 50 members or in the 50 people we need 1 WC and we need 1 lavatory in terms of 50 people. No bathtub because I'm dealing with educational. It's not a residential thing, so we did not need this. But in residential also, restaurants and hotel comes. So in there we do have a bathtubs over here, but as if now no over here. So this is 1 per 100. What is this? This is a drinking fountain what you see. And others, if you see, this is 1 servicing. As it's an educational thing, they might bring the defense or something, so we need 1 servicing for them. Moreover, let's see one more thing over here. Now let's talk about a residential thing. So if you see in here over here, an apartment house, this is 1 per dwelling unit. Now what do you mean by this? That means per family we need 1 WC, 1 lavatory and 1 dwelling unit. Again in terms of what? The bathtub for sure we need over here, and nothing in terms of what? The drinking fountain, no need, and 1 kitchen sink per dwelling unit. Okay, and moreover let's see one more thing, nothing but yeah, if you talk about business, if you're falling under this category, assembly, in this also we do have subcategories. If you see over here, so this is A1, A2, A3 and all this. So you need to check you're falling under which category, and these are the basic things over here like WC, lavatories, bathtub, drinking fountains and others. So these are the minimum number of required plumbing fixtures. Now one can find out the number of fixtures in such a manner, like if you know the number of people. And how you can find out the number of people, for example, as I just now said, this the architect or the main contractor has not been given us the fixtures, and he said that you proceed up with this. So do not get worried, I can make use of this table and I can proceed in this manner, saying this, okay, I have taken this values from this XYZ code, like I'm doing right now with 2009 International Plumbing Code. So I can just find out the occupancy over here, and only thing what I need to find out apart from this is, moreover, I need to find out the furniture layout, from where I can find out the number of people in the project. Okay, when I find out, for example, I got to know this is like, now I'll say you, for example, I'm going with theater and all this, and here he is saying 125. I got 300 people in male and 300 people in female. So what I need to do, 1 per 125. What that means, in 125 people, 1 WC is more than enough as per the probability. Same in female, 1 per 65. That means in 65 female, 1 WC is sufficient as per the probability. Now this values is as per the probability. That's what I said, now I hope you got what is the use of the codes over here. Now there is 300 people, means I need to go for sure. I actually, if I go with 2 WCs, it's 250 only, but I need to go for 3 for sure, because it no problem, because this is 125, but I have only 300 people. But for 50 people, what about 50 people? Because if I go with 2 WCs over here in the male, this is 125, 125, this goes to 250, but again 50 remains. So for safer side, I'll be going with 3 WCs in this theater in terms of male toilets, and in the female area in the toilet, what I'll be doing, I'll be having 3 WCs over there, like 300 and 300. So in this male toilets and female toilets, 3 WCs and 3 WCs. Same laboratories, 1 per 200. Again I'll be going with 2 laboratories in terms of male and in terms of female. Why? Because 1 per 200, but actual things is what I'm having is 300 male and 300 female capacity in that theater. Okay, and now in the bathtubs, no need of bathtub, it's not residential, so no need of this. And drinking fountain, 1 per 500. So this is 600 people, I'll be again going for 2 drinking fountains. Okay, and 1 servicing. So in this manner, I can find out the minimum number of required plumbing fixtures as per this code. Okay, so this is the things over here what we have seen. Now let's proceed further. What are the systems what we are gonna see? We're gonna see in this is domestic cold water system, domestic hot water, garden water sprinkler system, drainage system, vent and stonage. This all will be covered one by one, and we'll be seeing this later on. Okay, so chapter 1, let's talk about. Now introduction. Plumbing is a system of piping. We have already read this. Apparatus and fixture of water, distribution and disposal within a building, and we'll be seeing this later on project. Now some simple chemistry about the water. So water is a chemical compound, everyone knows this. It is a liquid which boils at 100 degrees centigrade and freezes at 0 degrees centigrade and consists of water molecules. Everyone knows this. Okay, which boils at 100 degrees and freezes at 0 degrees centigrade, and it consists of water molecules. Now each water molecule contains of 2 hydrogen atoms joined to 1 oxygen atom. It has a chemical formula H2O, everyone knows this. It is an excellent solvent, and as a result, normal drinking water contains dissolved substances such as iron, manganese, calcium, magnesium, sulfate and fluoride. So these are some solvents over here and dissolved substances, and which is good for health, we'll be seeing. It also contains dissolved gases including oxygen, nitrogen and carbon dioxide. Many of the above minerals are essential for the health and proper growth of our bodies. So that means the minerals what we have just now seen above, they are very important or essential, plays a very important role in our day-to-day life, for maintaining our health and proper growth for our bodies too, for our growing kids and all this. So the presence of these minerals usually imparts a much more pleasant taste to water. Now pH stands for potential of hydrogen. Now I think you people have seen the pH of water in some kinds of this water bottles and something, or else I think you have been heard about this pH of water and all this. pH stands for potential of hydrogen. What is it? I'll say you. It refers to the hydrogen ion concentration in a solution. It is the measure of the acidity or alkalinity of a solution. The pH value range from 0 to 14 on a pH scale. So therefore I do have a pH scale which measures from 0 to 14, and in this range, the moment I test a water, if I get a value in between 0 to 14, then I can say basically this 0 to 14 is nothing but acidic or alkalinity. That means the water is acidic in nature or it is alkaline in nature. I'll get to know. Okay, so what happens over here is the moment we measure this, the pH of natural water varies approximately 6 to 8. That means the water in a natural way, which is a natural water, it varies. The range of this is what, 6 to 8 pH. Okay, and it depends on the type of the rock which the water passes. In some areas it might be as low as 4, example Gracia, due to acidic rain. Now it depends, I mean the pH of the water depends on what? Mostly it is generally at 6 to 8, but it depends on what, because whenever the water is falling or the rainfall, it gets absorbed into it, and when the water is being digged or when it is being made to pass through, or we make a way, so it depends on the type of rock from which the water has been passing, which has been contacted with that rock. It depends on that also. But what happens in some cases, it will be so low also that it goes to 4 also due to, but what happens in that area, because of the acidic rain, it becomes very low. Okay, now 0, 1, 2, 3, 4 to 6 is what is acidic, I'll say. Okay, less than 6 you can say, or till 6 you can say is what, acidic, the solution. Okay, lesser than 7 and after the 7 the solution is alkaline. So the pH scale, which ranges from 0 to 14, measures acidity and alkalinity. Acidity increases as the pH value decreases, and the alkalinity increases as the pH value increases. So pH less than 7 is what? Solution is acidic. Again, it's not good. pH greater than 7, solution is alkaline. So this is how this, mostly this should be a best thing over here. This is neutral. So this is the best water you can say. So this is the most highest acidic, 1, 2, 3, 4, 5, 6 over here, and this is neutral. Again, this is alkaline, highest alkalinity till 14. Okay, what are the sources of the water over here? So this is dam, river, lakes, wells and bore. Okay, and we do have hard water and soft water. What is this hard water and soft water? Soft water contains little or no dissolved solids. It is often brownish or yellow in color. Now hard water on the other hand will have a high calcium or manganese salt content. We know this, we have seen also when you compare with the hard water and soft water. Hard water you can say which having as a high salt content, as we know this, and we can visibly see the scaling factor on a vessel or any utensil in which we carry the hard water. You can see the scaling factor over there, or the scales over there on that. Soft water is not, because it is having very less content of the salt when compared with the hard water, because it is treated water. Okay, so that's what, and how you can differentiate this both waters, because when hard water, if you have applied with the soap or shaken with the soap, it is not readily giving you the lather. When if you have a same kind of solution, if you apply with the same kind of thing with the in means of a soft water, I mean some kind of solution, you've shaken that, it gives you rich lather over there. So this is the difference. You can easily do this kind of experiment. You can find out why, because of the high salt content and what high calcium content, it could not give a rich lather and not that easily also. But when compared with soft water as a treated water, it gives you a rich lather over here within the same time. The table below is what subdivided hard and soft water in various classes depending upon the hardness. Now it's ppm over here, just as percentage means out of 100, so parts per million, or ppm means out of a million, same thing. Like 100 is what percentage we say it out of 100, and ppm is nothing but in terms of parts per million. That means we are talking about a percentage in a million. Usually describe the concentration of something in water or soil. So 1 ppm is equals to 1 milligram of something per liter. Now you can identify ppm is nothing but 1 mg of something in per liter of water. Okay, so or 1 milligram of something in per kilo in the soil. Now soft water class is what it has 0 to 50 ppm. Cooking and drinking it can be used for. Moderately soft water depends, the ppm is percentage, I mean in terms of parts per million, is 50 to 100 cooking and drinking. Slightly hard is 100 to 150 washing and cleaning. Moderate hard is 150 to 200. Hard is over 200. So this is what a kind of percentage, as you know this, nothing but 1 mg of something I said in terms of per liter of water. So if you can measure this, if you got this, okay, this is much as ppm, so you can visualize, okay, this is a soft water because I got a value less than 50, so that is for sure a soft water. Moderate soft, which can be again used for cooking and drinking, 50 to 100. Slightly hard, above 100 to 150. So these are the ranges. Okay, now let's talk about plumbing fixtures, what we was dealing about this. So plumbing fixture is nothing but a plumbing fixture is an exchangeable device which can be connected to a plumbing system to deliver and to drain water. Plumbing fixture is nothing but, I can say, a kind of equipment, you can say, not exactly a equipment, it is a part of a system to which the supply of the water is being given, and at the same time the drain system is also being connected to this fixtures. So in short, I can say it's an exchangeable device. Why exchanging? It is exchangeable device. It's connecting to the plumbing system to deliver, that means to demand the water, at the same time it needs to be drain out the water. So very first thing what you're seeing is over here WC, nothing but a water closet. Generally people say WC. WC stands for water closet. Now what WC, what you're about to see or what you're seeing is nothing but a Western water closet or European, the same thing. So this is, oh, this is only the WC, this is something else, do not get confused. What is this? This is not a WC. Only this bowl what you're seeing is a WC over here, or a toilet seat over here with lid, and this is bowl. This is only a WC. Now second kind, we do have different classifications. Second kind of WC is over here, Eastern Indian or Arabic. If you see, this is a WC, one more. And third one is universal. Now universal WC is something which is combination of Eastern and what, Western. As you can see, generally you will not be seeing this in common, because it will be mostly seen in commercial places, because where the tourist comes. And now you can take an example of a restaurant or hotel, because different people, what they have different kind of usage. So what, as per their need, they can make use of this. So they might use as a Western, they might use as a what, Arabic. As you can see some pedestals over here, so one can use as per their habit over here. The second thing we do have is a second fixture. Second fixture is what, the flushing system of WC and urinals. This is a gravity flush tank, generally and commonly seen in our household also. We do have the same tank. Nothing but by means of a gravity we are like flushing. The flushing is being done by of the gravity system, I mean nothing but the gravity force over here we do have over here. Okay, and what happens is this flushes and cleanups with the bowl. Second, in this also we do have classification flushometer tank. Now flushometer tank is something different when compared with a gravity flush tank. It's the usage is same. It is being used for the same thing, for the flushing purpose, to clean up the bowl. Okay, in terms whatever the WC is. So now here this is different because I do have an internals over here piston, which creates additional air pressure and less amount of water when compared with this is what the flushing gravity flushing tank. And gravity flush tank demands 1.6 gallons per flush of the water, and this demands some less amount of water when compared with the gravity flush tank, and this is more effective when compared with a gravity flushing tank, because here I'm having is two things over here. Very first is water, what I do have in the gravity flush tank also, but some additional thing over here, additional air pressure, because I do have a piston over here which is compressed over here within the air. So the moment this lever or this knob is pressed, what happens, air and mixture combined, which is under pressure, it comes an effective cleaning when compared with the gravity flush tank. Third one is flush valve. Now flush valve is something which demands a huge amount of water. First of all, it demands 3 times more of water when compared with the WC. Now don't get confused that you have seen this with the urinals. Yes, what you see is not exactly a flush valve, because I am talking about a flush valve related to the WCs, not for the urinals over here, because urinals has very less amount of pressure and flow also. But here in flush valve, it demands a huge amount of water first of all, and at the same time, what, 3 times, as I said you, it demands 3 times more water. Okay, and very huge amount of pressure. So, and this is generally being seen with the WCs and all this, not commonly, because this will be concealed, so you need to check, and this will be directly connected with the pipe, always connected. This is the same mechanism, just again for the flushing purpose, so flushing valve over here. Now the third thing, what we are about to see is nothing but a laboratory. Laboratory is nothing but a wash basin. There are two categories over here. This is normal laboratory and this is laboratory with pedestal. Nothing but, as you can see, can you see this pipes over here? This is nothing but just to hide this, because if I'm having a laboratory inside my project, it might be in between, like it might be in hall or something, then it does not give a pleasant looks, it affects the interior. So for that reason I need to have this laboratory with pedestal. Now laboratory is nothing but, as I said just now, it's nothing but a wash basin. As per the standards, always remember, laboratory demands hot and cold water. That means it demands cold water as well as the hot water. Okay, and we know this, the right side is always used for the cold water and the left side is always used for the hot water. Okay, and we do get different things over here. I do have faucet, I do have mixers over here. Okay, let's see that later on. So now the third thing over here in the subcategory is nothing but a laboratory tray. The laboratory tray is something n number of people getting served at the same time. Now you can take an example, in some function halls we do have same laboratory trays, this kind of thing. And in the ablution area also, you can say this is a laboratory tray, a channel from where a drain in only in one thing. Okay, so this you can say a laboratory tray. And next fixture is a bathtub, nothing but just to have a bath. The standard size over here is 1/2 inch. What is this we're given for? Okay, this is a bathtub just for having a bath, and this is a Whirlpool bathtub. Difference between that bathtub and this bathtub, this has a pressure points, as you can see. These are all our pressure points. Now it can be used as a massager too. So generally and commonly you'll be seeing this kind of things in what gyms and sauna centers for having a massage kind of thing. Okay, and as you can see, there is a kind of a control panel over here from where you can increase or decrease the jet of water. I mean, from over here a jet of water comes, and that jet of water is the thing which gives you act as a pressure points and gives you a massage kind of thing. Okay, so you can increase and decrease the jet, the things over here, and you can increase and decrease the temperature too over here from over here, controlling in this manner. Okay, manually. The next fixture is nothing but a shower. In shower also we do have some categories. What we are seeing right now is a shower head, which is nothing but which is installed, or which is installed on the wall mounted. You can see this is wall mounted, that is above head. That's why it's said as a shower head. And this would be generally on the 7 feet of height. Okay, just used for what? Having the bath in this manner. So it's a shower head. Now it's a shower tray over here. Now here is not talking about the shower, here we are talking about the shower tray, and this white color what you're seeing is a shower tray. Now this will be generally seen in somewhere in the bathrooms, where this is the this is seen, this is being used for what? Just to drain out the water. The water should not come in this area, neither in this area. Okay, so now you can see there is one more kind of a shower over here. This is called as a hand shower, you can say, because as you can see we have some hose kind of pipe over here connected with this shower, and this has some flexibility because it's not fixed, because it's a hose pipe connected to this shower which is delivering water. So I have some kind of flexibility, but I'm not talking about this shower, the shower tray over here. And this shower tray is responsible, and we have a little bit slope over here. You can see the water has been going in this direction from this shower tray, this white color shower tray. The water drains in this manner from this drain point. So this is a shower tray. And next is bidet. Now bidet is something generally being used one after the this will be mostly beside the WCs. One can use after the WC usage, and this is mostly being seen in high class villas and all this, and it can be used for handicapped people also. This is called as a baby cleaning also. And this also generally is being designed on a basis of cold and hot water supplies. You can see these knobs. This works in this manner. A jet of water is being coming and effective cleaning, and from over here the drainage goes. This is for cold, and this might be for hot. And this shower, always remember, demands hot or cold. It's only hot, right? Or it might be cold also, but generally we do have showers going with hot and cold because it demands both. And we do have what? A mixer over below the shower, isn't it? So I can mix the water over here. Floor drain, nothing but unwanted water in the floor area or any area I can make use to drain, okay, at the drain point. So this is generally you'll be seeing in the bathrooms and all this, and in between lobbies and all this, just for what? Unwanted air, unwanted water to be cleaned out. So one more fixture. Next is a urinal. Urinal is something what you can see. This is a urinals over here. This urinal is for the kids. As you can see, the height of this urinal is a bit smaller, and this is for adults over here. Now this is one more fixture because again it demands water, as well as same time it will be draining this waste over here what is being produced. So this, if you can see, I'm having is what one flow this I mean yeah, sorry, I'm having as a flush valve over here. So flush valve, you can see. Now don't compare, as I said, now don't compare with this with the laboratories, because if you see over here, this laboratories will be having very this flush valves will be having very small amount of the water, because if I have a huge pressure over here or a huge amount of water for this cleaning, it might disturb, or this kind of things will be getting on the clothes. So it's not there. So you could not compare this with the flush valve. What I said, it demands huge amount of water, so don't get confused that no, it's technically wrong if I say this will not the same flush valve what I was talking about. That flush valve is being again installed in respect to the WCs only. Okay, next fixture is nothing but a kitchen sink, and you can see this is a kitchen sink. In this also we do have some categories in the kitchen sink, like single bowl, double bowl. The material of this kitchen sink will be mostly is what stainless steel, as it's in the kitchen area and mostly in the water area. So this is a kitchen sink over here. Okay, and this is a service sink, and in this we do have two sinks over here, single bowl and double bowl, as per the application, as per the usage. This is single and double, you can say. So what happens over here, as per the application, this will be increasing or decreasing. Like a hotel industry and all this, I'll be having double bowls over there. Now this is service sink. Now this might be a service sink. Now for a janitor's clinic, you can say, or this can be a kind of a portable sink, you can say nowadays. Next is a dishwasher. Dishwasher is nothing but again a kind of equipment actually. Now this equipment is need to be arranged in such a manner that it's been utilized, or it's been used for what, for the cleaning of the complete utensils in the kitchen area. All I need to is just place the thing with respect to the order. Like example, plates should be in this manner, spoons and whatever the things, items from the kitchen should be placed in systematical order and added with the detergent, and on that's it, will clean the complete utensils. Okay, so this only demands only hot water, not the cold plus hot, because I'm dealing with what, cleaning of the utensils. Ablution tap, as I said, this is a peak demand area. You can see all the taps will be used at the same time. This design only for the peak demand. This is cold and hot it might be. Electronic flush valve. Now the electronic flush valve is nowadays used in terms of WCs. It's nothing but a kind, it works on an infrared sensor. Okay, as you can see, this red color is nothing but an infrared sensor. What the sensor does is it senses the temperature of the human body, and what it does, it releases some amount of water. And I think you people have observed that when the moment you place hand under the laboratories, it delivers some amount of water for the cleaning of the hand. Right, so what happens, it's a green building concept actually. This will be a bit expensive, but nowadays they are using this just to save the natural resources like water over here. So what happened, it delivers a limited amount of water, then automatically shut off. So this has its advantages over here. Like what advantages? First of all is water saving. And what happens, second thing, mostly it is been proposed in terms of hospitals and all this, because there are very less chances of the diseases spreading. For example, any guy is been having some disease which is spreading, then what we need to do is we need to have this kind of infrared sensors over there, so that no one will be touching the taps and all this, or this electronic flushing valve, because no need to on and off, because automatically it senses the temperature when it is nearby human body temperature, and the sensor senses and releases some amount of water. So now it can be seen in laboratories. Okay, but it can be used for what, urinals also. I think you have seen this, isn't it? Because when anyone is done with the urinal, automatically flush will be done, no need to press and flush in terms of urinals. Okay, but it's good for flushing purpose in terms of urinals and all this, but it's very bad. It has some advantages that, okay, it's water saving and all this, but it has some disadvantages too at the same time. Now disadvantages is this, it cannot be used as a mixer over here. Either I could have only cold water or hot water. Okay, if it's a mixer, that means I need to mix up a water. I could not do the mixing, either cold or either hot I can serve over here. So in laboratories, if I'm using, the disadvantage is only cold I can serve, or only hot. It's not a mixer over here. So in this manner, electronic flushing valve, good concept, good to be used, but again it has some disadvantages what I talk. Now drinking fountain. Drinking fountain is something, this will be seen in generally in public places. It has different scenarios. It has some kind of button to press at the top, so this the water comes in this kind of a jet of fountain, or in this manner. All you need to just place the mouth under this and drink the water, or else you can use your hand and drink the water in this manner. The main thing over here is just not to touch this thing, just to maintain what, the hygiene. And this will be generally, as I said, this will be mostly seen in the public places, especially like railway station, airports and all this. Why? Because if anyone might be having any diseases, it's not been spread easily. And without a container, always remember, and it demands what, a potable water or a normal water, not cold, not hot water. So municipal water, I can say, potable water is. Next is cooling tower. Now do not get confused why cooling tower. Now cooling tower is just again used because this is again actually HVAC part, but this why I'm showing you over here is because whatever the piping I'm dealing with at the moment, I said piping is a set of plumbing is a set of piping. So this HVAC, chilled water piping and firefighting piping also comes under plumbing. So just for your information, we have added this image over here. Now water tap. What do you mean by water taps? Under water taps, first of all, what you're about to see is hose bib. Hose bib is something where you have some option to attach a pipe so that you can carry the water in any direction, and this is generally been in the parking area and in the rooftop area. And the why this is being placed over there, or why we have hose bibs in this area, for the maintenance or the cleaning purpose, we do have hose bibs over here. Second is faucet. Now faucet is this looks like, and as you can see, how to identify whether this is a faucet or no. According to me, this is a faucet and a mixer. As I said, now this red and blue color indicates on my left hand side is a hot water, and this on my right hand side is a cold water, and this is a mixer too. This faucet is with chrome coated. If you can see, this chrome coated, this color, that's why. And now how you can visualize faucet is something online, that what you're seeing. The moment I place hand under the faucet, I'll be getting is what, a very refined kind of thing. Okay, a smooth kind of flow under my hand. Okay, and I can observe is what I'll be having is what, an air bubbles over here on my hand. So I can see, okay, this is a faucet, and faucet always works in principle of angle valve, because a slightly opening of the faucet is what I'll be getting the enough amount of water. That means enough amount represents to what, a sufficient amount of water so that the purpose can be served. So always remember, faucet works on an angle valve principle. And how you can visualize, first of all, slightly open, you'll be getting a sufficient amount of water so that the purpose can be uh, served. And the moment you place the hand under this, you can sense a very smooth pressure and you'll be getting air bubbles, so you can identify, okay, this is a faucet. Now let's talk about the tap. Now tap works on the principle of angle valve, or sorry, gate valve. Why? Because if you see this, if I twist this to one rotation complete, I'll be getting small amount of water. The moment I do 2, 3, 4, the moment I am rotating in anti-clockwise, I'll be getting higher what flow from the tap. So this is how, because inside I do have a gate over there. Okay, the moment I am dealing with this, what happens, the moment I am rotating this, the gate is lifting up, and the water what is being increasing, because this gate is acting as a barrier over there. And this is not a regulating valve. The moment if I try to do this, the gate valve function, that's what I'm saying. So that's what, if you say over here, the difference between faucet and tap, a slightly open, I'll be getting required amount of water, a sufficient amount of water, I can say, because it's an angle valve principle. Now you know this, I think, if you have seen in a physical manner how angle valve works and how this gate valve works, because we do have a welded small gate over there. We need to rotate it. When the gate is completely lift, I'll be getting a water sufficient amount of. So make sure gate valve is not a regulating valve, and make sure this angle valve is a regulating valve. Okay, so I can, so if I try to do this with the gate valves or this tap, what happens, the gate inside these taps will be what, damaged because of the pressure. I could not use this. Okay, but the main thing over here, what I'm trying to say over here, you people, is the difference between this is this. What is the principle behind this is gate valve and the angle valve, but the tap is this, how it looks like, and this should be rotated 3 to 4 times in this manner. So at the last note, WC urinals and hose bib requires only cold water, dishwasher demands only hot water. So this is end of the chapter 1. Okay, and
So now let's proceed with the chapter 2. No, chapter 2 is something called as plumbing equipments. Now the moment I said equipment, you people are, equipment is nothing but a machine, can I say? Mechanical device which is used to bring some work, isn't it? So now we do have different pumps over here, and here the equipments are what? I can say equipments is over here, sand filters. I can say equipments is over here, a GRP tanks. I can say equipments is over here, the pumps, isn't it? Yes or no? And grease interceptors, hair interceptors, these are all comes under the equipment. So we'll be seeing both the equipments in the terms of plumbing, I mean in the terms of water supply and in the terms of drainage. So these are the equipments we'll be seeing. So very first equipment we'll be discussing about over here in the plumbing water side now. So is what the pumps over here. And as per we know, we are into the construction field. So because we are into M.E.P, so this is a construction field over here. So mostly the pumps as per this and all this we do have is what? Centrifugal or reciprocating, what kind of pumps we do use online? Yes, very good. Centrifugal. So mostly maximum the pumps what we are about to see over here all are centrifugal pumps. Okay. So now very first pump, what we will be seeing is a transfer pump. Now, what is a transfer pump? And the moment I say transfer pump, the word itself is saying that it is used to transfer something. It might be a liquid, it might be a fluid, it might be anything. Okay, but let me read it out in a very detailed manner. A transfer pump is a pump you can use to transfer liquid from one place to another place in general, or the pump which is used to transfer the water from underground tank or ground level tank to the overhead tank. This is exactly the transfer pump function is to. For example, I do have a G+3 building at the basement or at the ground floor. I do have is what shall I say, sump over there. Okay, I mean a sump, a reservoir if you're getting confused. And from that reservoir, I do have a water. I need a pump to pump up the water from this ground floor to the roof. I mean on the third floor roof. Okay, because there is 3 floors. Okay, on that third floor, I need to pump up this water. Okay, and where? In that tank, in the overhead tank, and I'll call it as overhead tank. Okay, so just this is just to suck from the ground floor, pump to that tank which is located on the third floor. This is what a transfer pump. Make sure this transfer pump is nowhere connected with the fixtures. Don't get confused online. This is directly from this tank to that tank. That's it. Hmm. Next. And next is what? A booster pump. Now, what do you mean by a booster pump? First of all, let me tell you what about booster pump. A booster pump is a pump which is generally being used to maintain the pressure, where the pressure is less, which is required. Okay, for example, I required 8 psi or 10 psi or 20 psi, where I do have a very less pressure. I need to maintain that pressure. So what I'll be doing, I'll be using this booster pumps just in order to maintain the pressure in the line. And in this also, we do have different things over here, because in boosters also we do have 2 different kinds of boosters. I'll just say you in a minute. So booster pump, as I said, you booster pumps are used where there is no pressure which has to be there, because we have studied yesterday that every fixture demands limited amount of water. I mean the required respective amount of water with the respective flow also, PSI. We have seen the pressure also, isn't it? To maintain this. If I'm not having that pressure, it will not work in a proper manner. Okay. So there are 2 kinds of boosters over there. One is called as main boosters, and second is we'll see that is pneumatic something we'll be saying. So first of all, let's talk about the main booster. What does the main booster does? The main booster is a pump, which is a booster pump. As I said, booster pump does what? So this will be at the ground floor. Okay, this will be at the ground floor or the very first floor of the building, and it will be in series connected 1 or 2 boosters. Okay, so now how it works is, for example, we do have a project of 6 floors of a building, and anyone is calling for a laboratory or anyone is calling for a shower at the 6th floor. Okay, so this pump will be getting on at the very next moment. This will be pumping up the water with the required pressure, with the required flow to the respective fixture. Okay, always maintaining the pressure in line. Okay, where there is less pressure. Now, how we'll be having less pressure? We'll be seeing this from the municipal, and as per the what kind of system we are proceeding with. We'll be studying more in detail about this. What directly connected to the fixtures. Anyone is calling for any fixture, the booster pump will get on, pump up the water with the respective fixture with the respective pressure. Okay. Same thing. Main booster pump pumping directly from the series to all the building fixtures, as I said you. But where I was saying previously, what kind of system? Transfer pump. I said you transfer pump deals with only from this tank to that tank. It is nowhere connected to the fixtures. But here what happens? From this, it has been sucking the water and directly pumping the water to the directly to the fixture, where the available pressure is not sufficient to reach the water to the floor. For example, I do have a pressure from the municipal of 20 psi. For example, inline 20 psi pounds per square inch, but I have a building of 6 floors. Just now I said you. So do you people think that 20 psi is more than enough from the municipal? I agree that I do have a water 24/7 from the municipal. I agree. Then I agree that it has a 20 psi from the municipal. Okay. But do you people think that water which is coming from the municipal, which is round the clock and with the required pressure, which is more than enough for 1 or 2 floors? But what about 3, 4, 5, 6? Can it go with that much of head? I need some external thing, a pump over there to pump there, isn't it? Yes or no? So I'm dropping there the pressure because I know this. What is it? The static pressure is increasing. So what happens? This pressure from the municipal will automatically decrease. So I need some external source over there, isn't it? So this is booster pumps directly connected to the fixtures. As I said, you said that the roof also. That is the next thing I'll show you. The next thing over here, and this is how booster set looks like. And you was talking about this hydro booster pump or hydro pneumatic booster pump also some people will be saying. So now what do you mean by this? As you can say, this is also in series, 2 pumps. There is a pressure tank, there is a control panel. Now this is placed at the roof. Can you see? This is one project actually. This is at the roof. This is actually a real image. I can't show you. This is an Indian project. Okay, this is at the roof. Now, like Anish, what you said, let me get back to you this and try to relate this. For example, Anish, you said that you have a gravity system over there. The water pumping from the transfer pump, it is going above and coming from the top. You said that ground floor will be having huge pressure. Agree. But at the same time, think what about the 6th floor, the where the overhead tank is being placed, only this much of slab, okay, like 5 inches or 6 inches, and afterwards the pipe is entering like maybe I'm saying 3 feet or 4 feet maximum. I'll be having a shower over there, isn't it? Because the floor FFL height is what? I'm talking about residential. We consider as 10 feet. Commercial, it might be 12 or 14, the maximum, isn't it? It depends. It is an airport or something, it might increase and increase more. So what happens? Do you think that I do get a required pressure because of this much of gravity force? From 6 will be very low pressure so to that fixtures on the 6th floor. Again, the water is traveling to the 5th. It will be somewhat a bit higher when compared with 6. It means the fixtures which are working at 6 will be more performing in a better manner on the floor 5. On the floor 4, more better. Floor 3 more. And at maximum pressure I will be getting where? At the ground floor. No. So to avoid this, and it is not recommended. So what I'll be doing, I'll be having this boosters over there. Boosters. So what boosters does is, again, whenever it is being taken care by the top floors, okay, top 3 floors generally, if it's a high-rise building. So generally top 3 floors is being utilized or designed a booster pump mostly for the top 3 floors because from the top 4th floor, if I calculate, the gravity force will be so much that it can attain that much of force, which is more than enough for the fixtures to perform in a proper manner. Okay, so, so there are 2 boosters there. One is main booster at the ground, one is hydro booster, which is at the top. And this would be very small because of what? Only top 3 floors. Okay, okay, Anish. It might be 1 or 2 floors also. Most very high rise, we go with calculation for top 3. Next one. This is a hot water circulating pump. Now what do you mean by this? A hot water circulating pump is nothing but is a circulator, small kind of pump, which is generally been installed in line. In line means on the line or in mid of the line, where what happens is it is just to suck the water from some area and it rotates the water in 360 degrees. So in short, if I'm not wrong, I can say it in this way: the starting point and the ending point is one and the same. For example, if I'm drawing a circle, I pinpoint it from over here, I have rotated a pen in 360 degrees and I'll be having a circle over there. At the starting point, that will be the same ending point also. Online, relating this. Yes or no? So what happens over here? No, Mudassir? It is a circulator which is forming a loop over there. For example, take example of a clock. Okay. So now this is we do have 3 needles. Let's talk about a seconds needle. It started from 12. It rotated 1 to 12 again. So it is what? 1 minute, isn't it? So to complete 1 minute, the starting point and the ending point same. So what happens in the circulator pump? Generally in the circulators or hot water circulating pump, what we are about to deal up or what we are seeing, it is been generally seen in terms of central system. A central system means the central heater system. So what happens? It sucks the water from the heater, it rotates to the complete hot water piping, okay, and again it is coming back to the heater. That's it. So this is a circulator. So it forms a loop complete. You understand loop, right, online? Take any one example online. This is a central heater I said you. Okay. Following online. Okay. So in this is first of all the city main line. As you can see, the cold water blue color, it's going in. And we know this is heating element over here. The water starts heating up. It might be any source, electricity or something, whatever it might be. The water is getting heated up now. The moment heated up, what happens? I'll be having a circulating pump over here. Like you can see over here, this is recirculation pump. It's actually not a hot water circulation pump. This is a recirculation pump. So what hot water circulation pump does is, this will be connected over here in this line, in this line, in this hot water line. Okay. What happens? It will suck the hot water in this manner. For example, this will pump up the water in this manner. It will go in this way. And again, it will pump the hot water in the heater. Why so? While the water has been transferring from here and here, I'll be having bathrooms over here, something, 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 something. So anyone calls for the hot water will be getting hot water at the very instant of time. Or else what happens, you people might have experienced this. If we don't have a hot water circulating pump, we need to wait for a certain amount of time till the cold water is being drained in the line of the hot water. Okay, when it is being drained, I'll be getting a cold water. Oh, sorry, hot water. So to avoid all this, always this hot water will be circulating in this way, like round and round, round and round. The complete piping, it will be pumping up the water. Anyone calls? Okay, the water is available right away at the moment. It is passing through that fixtures only. If it is not being used, what happens? The water is not being used. Okay, it will check. Okay, it's not being used. Again, the water will goes directly and dropped into the heater. Again, pumping. Again, same suction and all this. Yes, yes. That is why we need this hot water circulating pump, to avoid what? To avoid the wastage of the cold water. Okay, because as I said, na, anyone calls for the hot water, I'm opening the hot water, but I'll be getting first of all the cold water. I think you people have observed this. I need to wait for certain time that the cold water should drain out first of all. And that is again what we are spoiling, or we are like draining a water which can be used for no purpose. I drained it, and a natural resource. I need to save that, isn't it? So that's why I need this. Yes, automatic. It depends now. It depends on something like what? Like we'll be calculating this hot water circulating pump, which has the complete lining. I mean, how much the piping and all this, we'll be calculating and we'll selecting a pump. All it does is the moment the water level reaches, it sucks this and it will be serving this. Okay, by means of, we do have some kind of arrangements over there in terms of what we do have this. Okay, this much of level, it will be suction. And when the water level reaches like 60 degrees, for example, we do have some kind of things over there. Okay, 60 degrees, it will be suction, then it will be pumping up the water, because it has some commands. Okay, we have fixed this when it reaches, the heater reaches this much amount of water, it is heated by the thermostat or something, it has been interrelated. You have seen the control panels also over there, we do some settings over there. Okay, that is different. But this, what I'm saying right now, you're talking about an installation. Now what I'm saying is hot water circulating pump is used for this, which creates a loop and which is only and only just here to pump up the hot water in a loop from where it started. Again, it will go and drop the water over there. Why? Because to avoid all these things which causes this discomfort. Okay, and it creates a loop. That's it. I mean, at 360 degrees. Relate this online in a central system. It is used to circulate the hot water in central heating system. A circulator pump is a specific type of pump used to circulate gases, liquids or slurries in a closed circuit. This is very important. They are commonly found circulating water in central heating system. This is very small amount of pumps. Like this might be quarter HP or 0.5 HP I have seen maximum, because very small pumps just to rotate the water. It's nowhere something like pumping the water to G+6 or something, isn't it? Just in line. So this is a hot water circulating pump. Now let's see about a pump which might be used in terms of water as well as in the drainage side also. Submersible pump. The submersible pump is a pump which is totally submerged into the water. We have seen, if I show you this image, you will be getting this. For example, we do have bores done in our homes, and we do have these things only. This has been done a bore from this, and we do have, this is our pump over here, what you are saying. It is submerged and it will be having one electrical wire in this way. You have been seen this, isn't it? If this is completely, we open this, we do have a kind of mesh or a strainer over there. Behind that we do have a motor which rotates when, and this will be, this wire will be also be completely submerged. For example, if it's 100 feet, 100 feet of wire will be there and connections. The moment we open this, now this will be rotating energy because it's centrifugal pump again. So rotating energy will be converted to potential because potential is moving. Then potential will be converted to the pressure energy. Why? Because of this pressure, the water will be coming over here. We do have generally in our homes in India especially. Yes or no online? Yes, Anish. So this is the pump over here. Let me read it out for you people so it'll be much easier. A submersible pump, also called an electrical submersible pump, is a pump that can be fully submerged into water. That means it is completely dipped into the water. Okay, the motor is hermetically sealed and close coupled to the body of the pump. A submersible pump pushes water to the surface by converting rotatory energy into kinetic, then into pressure energy. What I said, the same thing. Okay, so this is one more kind of pump over here, the submersible pump. Why submersible? Because it's already into submerged into the water. Let's talk about the pressure tank now. The pressure tank is something we'll be seeing in the terms of boosters, in the terms of mostly in booster sets we'll be having, or in transfer pumps also we'll be having. No, sorry, not in transfer pumps. We'll be having only in the booster sets. Okay, so the combination of pressure tank and a pressure switch, the pressure tank and pressure switch, and the pump is what allows. Okay, first of all, let me tell you how it exactly works. For example, this is a pressure tank, what he's talking about, and this is a pump. This is a discharge. This might be a suction, or discharge me a discharge. Okay, and there is a pressure gauge. So now, for example, online, if this is a suction, the water is suction is being done from over here. The water first passes in this manner and fill this pressure tank, and this pressure tank is compressed with air over here. Okay, that's why it's called as pressurized tank also, because it has a compressed air over there. Okay, so it will be half filled over here, and we need to calculate this as per the pump inlet and outlet, or the cut in or cut off of the pump. Okay, so we need to design this also 50 liters, or generally you'll be seeing this pressure tank in commonly from the manufacturer. I'm saying 50 liters, 100 liters, 200 liters, 300 liters, 500 liters. I'm talking about residential and commercial. It might go to 3000 liters also. Now this is very dangerous thing. it might blast also because of excess pressure. Okay, so as according to me, this might be a discharge. As I can see is over here is what a pressure gauge. So I can say, okay, this much of pressure is being delivering in this, and this is a copper piping. So what happens, what this pressure tank does is, when it is being filled over with the water completely, and there is a complete top is the compressed air over there. Compressed means for sure it will be in pressure. So when it is being filled, the water goes and pump up the water to the respective fixture. So what happens if it is not there, for anyone, example, anyone is calling for any fixture, for example, 100 times a day in one floor. So the pump needs to get 100 times for one floor. And if example, if there is like kids in the home, if they are opening this and that, so what happens? The number of times the pump gets on and on and on. Booster set, which is not at all recommended, because we need to save the sources, as I said, your natural. So what happens, first of all, I'm increasing the running cost, because every time anyone is calling for any fixture, the pump needs to get on and pump up the water, first thing. Second thing is what, the pump needs a quick maintenance, because it is used so much of time, isn't it? So these are the things over it. To avoid all this, what happens, we need to calculate this pressure tank. And what is the function of pressure tank? First of all, let me tell you, pressure tank is something which has a pressurized air inside. If someone is calling for a limited amount of water requirements, for example, I can say for a lavatory or for a kitchen sink, not huge amount of water, like for not for the bathing and all this. So what happens? It will not allow the pump to on, because the water is under pressure, because the air is compressing from top. What happens? This will compress the water and send to the respective fixtures. So what happens? This will avoid the pump to on, okay, and to pump up the water. So this way the pressure tank is being utilized. Okay, so it is saving this running cost, and it is giving some more boosting to the life of the pump, I can say, in this manner. Okay, so we'll have a calculation, we'll see this later on. Just right now, just okay, see this, okay, how and why the pressure tank is being placed. It is a very good option, because only boosters, and that is expensive, it's a machine, so it needs a quick maintenance and all this. So if there is a sudden breakdown and all this, then there will be no water. To avoid all this, we do have this kind of tank over there, a pressure tank. Next, the dishwasher. Now again, we have already discussed this, but as I said, there are some more things. Again, it's been shown over here, because as I said, it's an equipment. So that's why here the details of this dishwasher has been given. So cold water pipe for you. Cold water pipe is pumped into the machine, I mean the dishwasher, from your home water supply. Okay, the heating element at the bottom of the machine powered by electricity. Once the temperature to a temperature of 30 to 60 degrees centigrade, an electric pump, we do have a pump also, a very small pump inside. That is from, again, we don't calculate this, because we generally, it's an equipment, so it automatically comes from the manufacturer. Okay, no need to worry about this pump. An electric pump at the bottom of the machine pumps the water up through the side walls in this manner. Okay, and from here a jet of water, here from here. Okay, and this way it goes on. It is used in kitchen to clean utensils with the hot water. Sorry. So let's see next equipment over here. That is nothing but a heater. So let's see what is a heater. It is used to heat the water to meet the demand of the building, or else I can say it is used to heat the water because we do require hot water, or else this is in general, but if I say in technical, this is also meaning the same. It is used to heat the water to meet the demand of the building. What demand? Hot water demand. Okay. So now this is general example of the heater, but in heater also we do have two categories. One is individual heater or a geyser or electric water heater. One and the same thing, individual heater or a geyser or electric water heater. Some people say EWH, some people say as a geyser, some people say as a unit water heater. That means a geyser, single bathroom, single heater over there. That's it. And one more is what? Central heater. Now central heater is something else. We'll be seeing now. So electrical water heater, or I can say geyser or unit water heater, it is used to supply the hot water to one or two bathrooms, but it is not recommended to have two bathrooms. But if there is no space or there is no kind of thing to install a heater over there in the bathroom and the bathroom is side by side, in that worst case then you can size up a big heater for two bathrooms, but not at all recommended because it's a geyser and maximum capacity what we have is over here is 50 liters. Okay, like we do get from 6 liters. Nowadays we are getting instant heaters also, portable, isn't it? Online 1 or 2 liters also we are getting instant water heaters also. So this is only for what? Single bathroom, because one shower or one lavatory, that's it, not more than that. So this might be 6 liters, 10 liters, 12, 18 as per the manufacturer. And what we have observed or what we have seen is it's not more than 50 liters. And 50 liters is a very huge amount of water capacity for the heater, isn't it? Because what? We don't directly use the complete hot water 50 liters. We'll do mixing also, isn't it? So this is a maximum capacity of 50 liters. Now next, as I said, and this is how exactly it looks like, and this is very simple. There'll be two lines. This is what, as you can see over here, this is cold water in, this is hot water out. That's it. So this might be how it exactly looks like. Okay, this is two lights over here, green and red. This is cold water inlet and hot water outlet from over here. That's it. Very simple. Now, as I said, we do have one more category of water. This is centralized heater over here. So this is central water heater, or some people say as a boiler. It's one and the same thing, boiler or central heater. So the moment I said central heater, I think you can relate this because you people are mostly engineering graduates in respective fields like mechanical, electrical, whatever it might be. Central system, you know, main one source, and it will be distributed to all the things over there. Right. So the same thing over here. Now, a central heater is something which is one complete heater for the complete project. So in short, I can say it is used to supply the hot water to multiple bathrooms. Very first thing. But the most important thing is what? It has a return line too. It's not so in here we have three pipes over here. If I'm dealing with a hot water central pump, I mean central pumping system over here, hot water. So I do have cold water, hot water supply, hot water return. Make sure you write down this. We'll be discussing this and we'll be sizing this different pipes over there when we deal up with the project, because I do deal up with the project. What we are about to deal up with the project in further is what I'm dealing with a central heating system. Because if it was a geyser unit, it does not make sense, because just in cold water in and hot water out, that's it. It's very simple, and like it will be done in like this. Okay, but central system, you need to think. That is the main catch over there. So we'll be seeing this. Cold water, hot water supply, and hot water return. So that's what. Always remember, central heater means it will be having a return circulation line. That means what? I do have a return line also. The water will be coming back. And this might go to 300 liters of maximum capacity. And you can see online over here. I do have one. What is this online? I do have two circulating pumps. Now why? First of all, is this a circulating pump online? Yes. Is this a circulating pump? Yes. Yes, it is. So I do require two circulating pumps, one for the hot water supply, one for the hot water return. Getting this? Because in supply I need to have one hot water circulating pump. Anyone is owning, I'll be getting. If there is no, then it will be returning back, right? In this manner. So two circulating pumps. Now this might be different modes of the heating. So this is one heater, central is a gas heater. The mode of this heating is done by a gas heating element and all that. And this is electricity. As you can see, some wires and all this over there. So this might be an electrical central heater. This might be a gas, as you can see this kind of mechanism. But the main thing is what? A central heater is nothing but serving the multiple bathrooms. That's it. Hot water with the return line. That's it. Now, let's talk about a grease interceptor and a grease trap. Now we are heading towards the drainage side. Now, many people have confusion that what is a grease interceptor and a grease trap. Now, let me tell you, A grease interceptor or a grease trap is something which is generally connected in the kitchen area or to the kitchen sink. What happens? Interceptor and grease trap. According to the UPC, Uniform Plumbing Code, the difference between grease trap and a grease interceptor is the flow rate of the wastewater the device can handle. Now, grease trap have a flow rate of less than 50 gallons per minute, where grease interceptors has a flow rate more than 50 GPM. Now, first of all, let me show you, this is how exactly a grease interceptor looks like. This is inlet from my left hand side and this is outlet. Here he is talking about the 50 GPM, the outlet. It might drain. If it is less than that, it is what? Grease trap. If it is delivering more than 50 gallons per minute, then it is what? Grease interceptor. So logically, grease interceptor is used for what? The high-rise buildings and all this. Now, why is being grease interceptor into plumbing, where it is being used and how it will gonna work? Grease interceptor is something that separates the grease. Now, what do you mean by grease? For example, this has been generally and most commonly connected to the kitchen sinks. For example, I do have a big building, residential, like a 30 floors of building, for example, online, and it's a residential. I do have a kitchen stack over there. Okay, one different single stack only for the kitchen drain for all the complete 30 floors. That pipe will be bringing over here and draining that water from all that kitchen sinks over here. And here I do have a partition. Can you see this online? A kind of a barrier here online, this one. Okay. Yes. And a strainer over here. Okay. This is strainer and this is outlet. Now what happens over here? Now, first of all, think in a logical manner. I'm talking, this has been only connected with the kitchen sinks I'm saying, isn't it? So in the kitchen sinks, we do design kitchen sink. It should be designed only cold or cold plus hot? Cold plus hot or hot water, because I'm dealing with a kitchen sink. Where in kitchen sink, what we're gonna do? We'll be what? Washing the utensils over there. So it might be very greasy also, or it might be oily, isn't it? So we need a hot water so that it might be easily washed off, isn't it? So what happens? The water which is being drained out from that kitchen sinks, it's been collected to one kitchen single stack and it's been coming down, and that water is lukewarm or hot water. According to me, it's hot water, not lukewarm. It will be a bit higher, not that so hot. It will be hot water or lukewarm or warm water, I can say. Not lukewarm, warm water, I can say. Okay. So what happens? As per this, I know this, and that water consists of so much of oil, greasy items inside it, isn't it? And I know this, when the water is being hot, that things mixes up, isn't it? I mean, the oil and grease items or the food items or the solid particles also will be drained. For example, some things it might be drained, what has been left into the plates and all this, it will be again drained out from there, isn't it? Trying to relate online, try to relate this. Okay. So now everything has been collected and everything has been drained over here. So we do have a small kind of thing over here. We'll reduce the flow and we'll deliver this. I mean, we'll discharge over here in this. So what happens whenever this is being discharged? Now, first of all, it has to fill. I mean, this compartment has to fill first of all. The moment this compartment is filled, the water will be drowning in this part. Okay. So what happens in this time? The first of all, the water came, and for example, just generalize. There is some water. Okay. Just neutralize everything. The example, take a glass and pour some water, and now the glass is completely filled. Now the glass is completely filled, for example, but still I'm pouring the water. What happens online? Overflows. Okay, but logically, can anyone say what happens? Say what happens? The water which is being entered previously, it will be what? Replaced by fresh water, because the fresh water will be going down and the water which has been settled down, it will be coming up and draining in the next compartment. Isn't it online? So what happens over here? But the moment continuous drain happens over there, so the old water which was warm or which was hot, and it was having everything combined in that. like oil, everything. Okay. And we know this when compared with oil and water, which has a less volume, which floats on water, oil automatically for sure, isn't it? So the moment we get the water over here, I'll be getting almost a huge amount of solid particles, like might be something, rice or whatever it might be. It will be collected mostly over here in this compartment because it is solid. So it will be settled down at the base for sure. Agree here online? Now, whenever again the same still water is coming, but there are chances because this water is again going into this, there are chances that some port particles again, I mean the solid particles will come over here. That's why I do have a strainer over here. Okay. Next is what? What happens when it is been draining out in this manner? So now as this is cooling down. Now again, first of all, this water has gone here. Again, it is coming here. In this meanwhile time, the water which was lukewarm or sorry, warm or hot, it will be getting cooled. The moment it gets cooled, the oil and the grease will be separated automatically because the temperature is not with the same. And we know this, oil floats on the water. So it goes at the top. Following online. So this is why grease interceptors is being used. Why? Because this is the main cause. If you don't have this kind of things, this might create some kind of combustion also. Because of what? If we don't do this, if I do all the things in one soil stack or one manhole, if there's a huge drain from the kitchens, for example, it's a restaurant, if I don't have a different thing, if I don't separate this grease and all this, because of what? Because of this oil and grease and all this, it have some kind of chemicals produced like hydrogen or something which is not at all suitable for humans. And one more thing I would like to add over here, whenever we are sizing a grease trap, it should be vented with at least 30 to 60 centimeters. Vent matlab that should be having an air gap. Yes, an air gap, and their air gap I'll be having one pipe inserted in that, that is called as vent pipe, so that the combustion or the gases should not form over there. It should be continuously vented. Following online centimeters. Okay, so now this is going over here, and what happens? Only the water from the kitchen will be collected over here. Now everything has been separated. The solid particles has been separated and the oil and grease has been separated, and it is floating on the surface of the water for sure. Okay. Now this water can be used online if there is a scarcity of water. So this water, if there is a scarcity of water, so this water will be sent to the utility area where they'll be treating at least, because again we'll be getting some sort of particles for sure again. So this water or this line will be going back to the utility area, and they'll be again processing it, again kind of filtering it, and they'll be sending it to one tank, and that tank will be connected to the WC flushing purpose. So I could not use this for the laboratories and all this, but this can be used for the flushing purpose for the WCs. Let me read quickly for you. Grease interceptors, however, with their larger size, are installed at the outside of the building or underground. Now, this is for the central system I am saying, if it's a big, huge building. But for example, if I talk about my homes, it will be very small, and generally they are having is what some small kind of grease interceptors or grease traps, I can say. In US, I don't know. I think Mr. Robert, you can answer me. I have seen, sir, in one video that they have some grease small traps below the lavatories also, isn't it? Lavatories and kitchen sinks. Mhm. No, that is something called as, you're saying about a mixer or chopper kind of thing where they are cutting the food items and all this. No, I have seen something, sir, which is a kind of grease traps below the lavatories and kitchen sink. Very small, very small. And that I have seen that they are having a falk out also below. I mean a kind of nut where you can open and drain it out. If there is, if there is need and maintenance, you can do that. That is, I don't like portable kind of thing, I can say, just for the house. Yeah, but just for the household. But for the bigger things, you need a grease interceptor, and that should be outside of the building, as I said, because the complete drain of that complete building over there. Got it? Okay, this is how the grease interceptor and grease trap. So let's have some. This is what it looks like. The working principle I've already explained you. Just let me read it out for you. In the most basic terms, a grease trap works by slowing down the flow of the warm or hot greasy water and allowing it to cool. As I said you, as the water cools, the grease and oil in the water separates out and floats to the top of the trap. That means on the surface of the water, isn't it? The cooler water minus the grease. That means the more cooler the water, it has been separating the grease and oil. Continues to flow down the pipe to the sewer. That means now next is what? The flow which is at the outlet. It will go to the sewer line, or if you want to reuse it, I said you, it will go to utility area for the flushing purpose. Now exactly, just see from the kitchen sink, there is a piping over here. This is, I can say, a stack over here. Now this is example. This is not a central thing, a small kind of interceptor just for our home, for example, you can say. This is how exactly what I said. This is a grease trap for my home. So this is one kitchen sink. So the water has been coming over here. As I said, there are some barriers over there. Can you see one barrier over here? Okay, now something which is being get, some solid particles will hit this and it'll try to settle down. Okay, now when it is being dry, the water goes in this way. Okay, this is being filled and the water can pass from here also because you have a little space here also. Now the water goes in this way and everything, the solid particles, the food solids, you can see it has been settled down. Now what happens over here? From here to here, it takes time, and to fill up this, it takes time. And don't worry, as the new water comes, the new water has been replacing with the old water. So old water continuously drains out because the new water is entering. Okay, and that old water is what? It is cooled down. The moment it is cooled down, as you can see, this is what yellow color, grease or oil, you can say. It has been separated because it is cooled now. Okay, so this is heat transfer taking place over here, I can say. It goes on. Okay, once it is being done, only the water. So now the water has been separated from the oil and grease. It is floating and the food particles also. And only the water will be sucked by this pipe, or this is one kind of thing. It's not been done. And this is only a secondary tank. They are saying it is not there, a special kind of thing. Okay, directly we'll be having this kind of pipe over here. Just for what? Just to the pipe outlet. Either it might be directly left to the sewer line. If you want, you can drain that, or else if you need, what you will be doing that you can reuse it by sending it to the utility area. But most important thing, it might combust, it might have a blast, and it happened in Qatar. So what you need to have this, as you can see, it should not be fully filled. So we need to design. This is called as water level is only this much. This is called as air gap. And you can see in this air gap, we are having is vent pipe over here. Can you see this online? Just to exhaust the gases over here. Okay, because this gases will be combustible and might have an explosion in future. Slowly. That is not at all accepted. That's why it is recommended to place up to the building also when you compare with the central systems. Okay, same thing. One more kind of installation, how it should be done. If you can see over here, same kind of thing. Okay, a small grease interceptor over here. Begin up with the session. Like yesterday we was about to end up with the chapter 2. We'll try to do it today. And we was dealing with the equipments in regards of the plumbing, and we have discussed some equipments in terms of the water supply and in some equipments in terms of drainage. As we was about to, yesterday was discussing about an equipment which is nothing but a grease interceptor, and that grease interceptor will be as a part of, I can say, a drainage kind of equipment over there, because it is generally in the drain side, isn't it? So let's further continue. What are the equipments more will commonly seen in the plumbing industry? So as we have seen this, and next is what? After once we have seen this, next equipment is what? I do have as a hair interceptor. Now the moment I tell you about hair interceptor, I think by the name itself you can identify or you can understand what is a hair interceptor. Now hair interceptor is a kind of interceptor which is being just here for, and this is generally being seen in the below in the shower area or in the shower drains. You'll be seeing this, or a laboratory tray. Why? Because at the moment someone has taken a bath and something, especially I'm saying, just try to visualize this, what happens is mostly the people, some who have, especially with ladies, when they have bath and all this, we'll be seeing there'll be n number of hairs on that, isn't it, on that floor drain and all this, and some hairs will be entering into the drain line, and isn't it, and sewer lines. What happens in that time is, after getting again and again repetition of this, it might clog or block the line in some day or some time after once has been. To avoid all this, what happens, we do have an air interceptor which is just here to just to separate the hairs, and only the water goes over here. Okay, this is an air interceptor, and there is no design criteria for this, but for the grease interceptor we do have a design criteria how to design up. Inshallah, at the time of drainage I'll let you know how to design or how to size up a grease interceptor. Okay, but as of now we are not into the designing, we are just learning what are the basics here, plumbing required, so that we have not yet started the designing part. The moment we start designing part after water side, we'll be proceeding with drainage. At that time we'll be inshallah dealing and we'll be saying how to design this or how to size a grease interceptor. So likewise, hair interceptor is nowhere designed, because hair interceptor does not have any calculation, because it generally comes from the company as in this as standard volumes like 40 mm it should be. Actually this for 38 it's wrong, because 1/2 is 40 mm, so it directly comes, okay, and directly outlet connected to what, under the shower tray. And you people know what is a shower tray, or you can say a floor drain in the bathroom, directly connected over there. So it acts as a mesh over here. For example, here is our floor drain. Online, try to relate this online in classroom. Here this would be the top, okay, the water is entering in this manner, okay, haze and all this, also this goes, actually this is not two pieces, this is a cross sectional area what they are trying to say. So we are having a complete strainer over here, as you can see this is strainer. So what happens when this hair, it gets stuck over here in the strainer, and only from this holes and all this the only water passes. Okay, now when this has been completely filled, the water goes up, and this way only the water comes out. Okay, and you can see we have a plug over here, a clean out, I can say. It is used for the maintenance purpose. As you can see here also, a small kind of thing, it's nowhere showing this is a clean out, so it's a clean out. You can open this, and it is generally used for the maintenance purpose. Okay, and once in 6 months and all this, you can just open, and this maintenance people will be maintaining this, I mean this, just removing this all the impurities or this hairs and all this which has been caught in terms of this bathroom area. Okay, so this is how a hair interceptor works. There is no sizing for this generally, as I said to you, because what sizing would be doing, because one bathroom, okay, we know this much of drain, that's it. Directly from the company's 1/2 inches or 40 mm, directly I'm attaching to that the floor drain in the terms of bathroom area. Okay, so no sizing over here. If now let's read about this. Now hair interceptor is designed to retain or hold the hair from the beauty shops, because in beauty shops they might take shower also, isn't it? Then hospitals or wherever, hair clogging, nothing but a blockage. I said you're clogging, clog in the pipe. Because of this, it might have a blockage after some time. Of the water system is a problem. The removable perforated stainless steel basket retains the accumulator hair before it can pass through the sanitary sewer system. The same thing, it is separating the hairs over here by means of a strainer, he is trying to say, and this is made up of mainly stainless steel, as you can see also, isn't it? You can see this. Okay, there is no sizing requirements for this interceptor, as if like we do have for the grease interceptor. There is no sizing required over here. All units are made with a 1/2, that is nothing but a 40 mm of standard pipe size. Okay, then size inlet and outlet are capable of handling drainage volumes of standard 1/2 pipe. That means on the both sides, this is also 1/2 and this is also 1/2 mostly. Okay, so and generally it can be seen under shower trays. I don't think so we do have over here and all this, but as per the standard projects and all this, mostly in Gulf countries, it is there over there. Mostly, especially if they have a different bathrooms for ladies and all this, you'll mostly find this. Okay, so this is a hair interceptor. Now next, having one more kind of interceptor, that is now oil interceptor. Now oil interceptor is generally being seen in the service stations. Now service stations, like example, I can say where the vehicles is being cleaned, okay, or else in terms of petroleum, petrol bunks or the gas stations, you'll be seeing this oil interceptors, because once anyone is maintaining or cleaning this area, because it's a petrol bunk and all this, there might be some kind of oil or something like any kind of, you can say petrol or grease or something over there. When they clean this, the water mixes in this way, isn't it? And that is what, that is combustible material, isn't it? So for that reason I need to separate this, both the things, oil and as well as the water, to avoid any explosion or to avoid any fire or something on that particular area. Likewise, this would be most commonly seen in terms of what, the servicing station, where they will be cleaning their vehicles and all this, because the moment they spray the water, okay, apart from on the complete vehicle, we know this, it touches to the oil and all this also, and the oil and some grease items will also be draining out when we are cleaning that. Okay, so generally and commonly you'll be seeing this oil interceptors. It's the same kind of concept. Likewise with the kitchen sink, you can say, only here is just in the application is changing, and that's why here it is called as oil interceptor, and the function is also same. It is just here to separate the oil. And again, one more thing I can say, again, oil is what, light in nature when compared with what, online, water. So obviously it will float. Okay, and what is done, they will be having one vehicle will be coming, and this will be doing a suction over there, and they'll be taking that, they'll be draining it. I'll say you how. First of all, let's read it out and how exactly it looks like. First of all, I think if people have seen in some gas stations and all this top kind of cover, it looks like a manhole. It's not a manhole, it's an oil interceptor over there. Okay, it is very hard and very rigid. Okay, it can bear a good weight also. I'll say you. So oil interceptors have been used in plumbing waste systems and wastewater systems, you can say, to help protect property, as I said, might be explosion, and the environment against explosion, fire and pollution. Oil interceptors are designed similar to the grease interceptors. Now you can relate. The function, the mechanism is 100% same as of the grease intercept. Classroom, any confusion? Same thing, same thing. Okay, just here to separate the oil. So oil interceptors are designed to similar to the grease interceptors. Both work on the same principle, that oils are lighter than water, and thus the gravity causes the oil to rise to the surface of the water, isn't it? Now, an oil interceptor can help separate oil from the water flows out of the car parks, as I said you, okay, and road gullies, and delivering vehicle storage units. This might be seen in the car parks area. Again, why I can say this car park area, because here if I say you, I can't say here, if I tell you about Gulf countries and all this, what happens in the car park area, uh, and in this country, especially in Gulf countries, there is a system that I could not have a vehicle which is very bad in condition, rusted or very bad like dust and all this. I could not, because they will challan me as per their laws and all this. So we do have a guy over there, Harris or something, who cleans this our vehicles. We give some amount of money, they will be washing our vehicle. So obviously there I need to have this oil interceptor, because when the moment he washes, it's not only the water which has been cleaned the car. In that water I'll be having is what mixes up with the oil also. That is combustible for sure, isn't it? So that's what. So we'll be seeing this in terms of the car parks area, or in the service station, or the petrol pump, or the gas stations, what I said you. Now how it works, the solid baffle plate, this one, the solid baffle plate opposite to the inlet to the oil interceptor diffuses the flow into the interceptor and lessens the turbulence of the oil laden water as it enters the intercepting chamber. Solids and sludge carried in the water are stopped by the baffles and collected in solid retaining bucket between the inlet and the flow retarding baffle. Such accumulation can then be removed. I think you're getting confusion. I'll say you. Now, if you see in a physical manner, if I have two things over here, like I do have an grease interceptor and I do have an oil interceptor very side by side, you could not judge which is what, because it looks almost the same as per the interior, because inlet and outlet, the shape will also be the same. But I can say, unless and until I open the lid and see, because in oil interceptor I'll be having much number of partitions, whereas in kitchen sink I do have only one baffle, I mean one hurdle over there. Only this one I said you, but here I'll be having 2 to 3 partitions, because I'm dealing with oil. So there are chances the oil might get over here, again some over here. So I'm doing what, I'm filtering more and more, because when I compare the oil, okay, he'll be here more, but still some amount of oil will be over here. Again, this will be filling, again some amount of oil will be over here. So again some amount of oil will be over here. That's why I'm creating more and more barriers over there, because I'm kind of what I'm doing. I'm kind of, I can say I'm straining over there, or means meshing over, I can say. I'm trying to minimize as much as oil. As you know this, again what happens at the top, I'll be getting this. And this is a kind of bucket over there. Here I'm having a bucket over there. The moment they open this, you'll be finding a bucket over here. Okay, so what they'll be doing, if it's small, they are taking this and dumping somewhere. Or else if it's for like a big thing over there where they are at the petrol bunks and all those gas stations, what happens, it is a explosion kind of thing, because the temperatures are very hot, so this could not be always kept in this way. So okay, they have some indications over there. Okay, now this is fill, they'll call. So the municipal, okay, they'll be coming and they'll be doing the same suction process like they do generally in Gulf. We don't have as what, the sewer process, I mean the drain line. We do have septic tanks mostly over there, isn't it, online? Nowadays they are doing, because of unfortunate rains and all this, isn't it? So nowadays they are doing. So what happens, they'll be calling, okay, they'll be removing this, they'll be pouring this pump, and they'll be sucking this oil and taking down. Okay, because it is combustible, because of that so huge temperatures also, this might cause an explosion. Not submersible pump, like same, I'm telling about a municipal vehicle, a big vehicle. I think you have seen in Gulf countries, which becomes, and it'll just suck from the soil pipe and all this. I mean all the sewage of the human excreta and all this, isn't it? And they'll suck this and they'll carry in their container in that, I mean a big container will be having in that vehicle. They'll be sucking and storing there, and they'll be dumping somewhere in like very far away from the city, isn't it? So that's what the same kind of thing, but they'll not dump this. They'll be keeping it to storage. They'll be using for some other process. Okay, so that is why this is not being easily directly delivered. Once this is being done, the oil is being separated. Now this can be, the only water can be drained out to the sewer line, because or else what happens, again it might create some gases and all this, and that is very dangerous. It might cause fire also, isn't it? So that's why it is not recommended to have this. So you need to do this process, then you need to leave into this line. Okay, and as I said, make sure this has n number of barriers over, like 2 to 3. Okay. Yes, oil interceptors. So oil interceptors are sized according to the rate of incoming flow. It might be then in gallons per minute, and that flow would be in GPM. That how much GPM, I mean how much the water or how much the oil and water is coming, that we need to first of all know, because based on that only I can size up the oil interceptor. For indoor applications, flow rate can be calculated by adding the maximum discharge rate of potential water sources. For example, a standard 3x4 hose connection will be discharged approximate of 10 GOM. Don't worry, this is something designing related. We'll be seeing this later on. But just now, just see. Example online, consider this is a gas station. Okay, from here the water and oil is mixes up. It's coming in over here. There is one barrel. Oh, okay, there's a huge space over there. Again, this should be vented. I said you, can you see this? This is again air gap over here. It should also be vented, right? So see, these are vent pipes over here, here, and here. It needs for sure, right? So now here it's coming, okay, and it's being dumped. Okay, now you can see this. This, can you see this online? This some dot kind of thing. This is nothing but oil, which is now, it has been dumped, and this is going above because it's a light in nature, and it is on the surface. Again, this oil is being dumping over here in this manner for sure. And I do have a very below line. I do have a line, and only the water has been going over here. And again, when this has been filling and discharging, now this will be sucking. So see, 1 barrier, 2 and 3 here, according to 1, 2 and 3, isn't it? So there will be a number of things. So this is just kind of one information, or you can try to relate this, how exactly it is working. The same principle, only here they are trying to remove the oil. Likewise with the grease interceptor, but here we do have a different more barriers, or I can say the baffles over here. It will be having more, or the number of partitions. You can relate in anything in which you can easy to understand. Okay, so these are some occupants what we are gonna see, or what we are gonna deal with and further. So I hope you got this chapter 2 also. Now we are done with the chapter 2. Let's proceed with the chapter 3 now. chapter 3 is very interesting. The chapter 3 is dealing up with the pipe fittings and accessories over here. 3 is very interesting because right now we are about to deal up with the pipe fittings and accessories. Now people have a very big confusion first of all in between the fittings and accessories. Pipe, everyone knows pipe is pipe. Generally, you know, kind of hollow thing or a tube from where any liquid passes or a fluid. Now, what do you mean by fittings and accessories? So many people have a misconception what is fitting and what is accessory. So first of all, let me tell you, fittings is something which is extra kind of thing or just to change the direction of the flow, and that includes what? Elbow, T, reducers, cross, union, nipples and all this, and this will be in line, isn't it? Just to make a complete plumbing system, we'll be having this fittings, and for sure we need to have, isn't it? For example, I'll say you, as per the standard, I'm dealing with any kind of pipe. It might be a plastic PVC, PPR, or CUPVC, CPVC. As per the manufacturer, I get a standard of 6 meters of length. But my length in the project is like 60 meters. Then I need some fittings to join this pipe, and there is some turnings over there, so I need some more fittings. That is elbow, and I need to take and I need to have some more fittings. Like example, I have a 30 GPM starting from the pump, but from near ending of the project, like on the very top floor, I'll not be needing 30 GPM because at the ground floor I might be needing, because it needs to cover all that complete floors. At the topmost floor, I'll be getting what, 10 or 5 GPM, more than enough. So I need to reducer. I need a reducer over there. So these are all the things which is called as fittings. We'll be discussing this in detail. And now accessories might be, I can say, thermometers, pressure gauge, gate valves, and all. These are all accessories. Okay, so let's start up with the very first pipes fitting. Many people are aware of this. The very first fitting over here we're about to see is an elbow. As you can see the shape, it's in kind of elbow over here. And this elbow also, we do have two categories over there. One is 45 degrees and another is 90 degrees. By seeing this, you can say this is 45 or 90 online in classroom. Very good, 45. And why elbow is used? For the change of direction. But if you see over here, there is one more thing. Now elbow, 45 degree elbow we are about to see. 45 degree elbow is installed between the pipe to change the direction of the pipe by 45 degrees. That means if I need to change the water, example is going in this way, I need to get in this way because I'm having one more pipe connected over here. Okay, so I need this 45 degrees of flow. Now it depends on the installation. If I need 90 as per the site conditions, I'll be using. If I need 45, I'll be using this. Okay, generally we're seeing this. This is a UPVC. You'll be getting this in GI, whatever the metal you're using, will be getting this. So this is a 45 degree elbow, and the other is what, a 90 degree of elbow. And again, the same kind of thing, but only the changes over here, just to change the direction of the fluid by the 90 degrees. And you can see over here in this way, this is 90, because we know this. Out of 360, we have learned 45, 45, 90. Then again what? Yes or no? Because if we divide this rotation circle, so you can, I think you can visualize or you can imagine, because we have studied this in our previous classes, I mean in our school days. So this is 90 degrees is in this way, just the same thing. So 90 degree elbow is installed between the pipe to change the direction of the pipe by 90 degrees. So this is one more fitting. The next is T. Now where is T used? Now T is used in somewhere in such area where I do have 3 connections or 3 outlets, 1 inlet and 2 outlets. Okay, but in this also we do have some deviations. Very first is what, an equal T, and one is unequal T. So first of all, talk about an equal T. What exact is an equal T? When the size of the branch and the header is same, equal T is used. Now you can easily relate. It might be one inlet, or it might be outlet and outlet. Now, or it might be inlet, this and this might be outlet, or it might be inlet, this and this might be outlet. Okay, but the main thing why I'm saying is equal T, because if you see the diameter over it will be same with this and with this. So it might be a header, or it might be a header, or it might be a header. It is regardless with me, because all the 3 things are same. See, as I said, when the size of the branch is same as the header, then I'll be using is what? A equal T. Or else if I do have a lesser flow, then unequality comes into picture. And unequality is in this way. Unequality, or some people say as a reducer T. Now you can link this. See online. So this might be inlet or this might be inlet for sure, and this will be for sure outlet because it's a reducing thing over here. Okay, so unequal T or a reducer T when the branch size is less than that of the header. This might be header or this might be header. So this is a branch line. I'll be using is what? Unequal or a reducer T. Welcome. So let's further proceed with this now. Okay, one important thing I forgot to say because in some communication with the people. What is the importance over here? I'm discussing fittings with you in such detail because fitting plays a major and an important role in the plumbing industry because some fittings causes a huge pressure drop or the friction loss because of their size, because of their shape, what it is made. So now the maximum pressure drop created in the fittings are, very first is elbow, T, cross. Okay, I'll say you. Let's write it down. Elbow, T and cross. Because if you see over here in elbow, the direction was going, water was going in this way. We are turning it. So it touches over here and there is a friction loss over there, isn't it? Or head loss. So why I'm saying, because we need to consider at the time of pump selection, because the number of fitting increases, it will increase the head capacity also, because it should overcome, right? That is why we are having a pump. This should overcome all the losses inside the piping. And we know this for sure. This will be having a huge impact on this. Okay, so that is why. And apart from all this fitting, not all the fittings, every fitting has, but this is causing a huge loss in this because of this shape. Okay, so elbow, T and cross. Crosses is the most very kind of very tough thing over here. I don't think so. I need some answers because in Kuwait they are very strictly against it. They will not allow to install this. It is very dangerous. They'll say no, khalas, you can't. You do anything. So we'll be going with 290s over there. Okay. So we should not, because what happens also, well, let's see, cross. A cross fitting has an opening on all four of its end, 1, 2, 3 and 4. This is opening or 4 ends, and can connect 4 pipes. That is 1 inlet and 3 outlets. It might be from anywhere, from here, here and here. Okay. Now cross fitting come with 3 inlets and an outlet or 3. It might be 3 inlets or 3 outlets. It might be anything. Okay. 3 inlets बोल सकते हैं या 3 outlets बोल सकते हैं. It might be. मतलब एक inlet बोल सकते हैं या 3 inlets बोल सकते हैं. If it is 1 inlet, then 3 outlets. If it's 3 inlet, then 1 outlet. Vice versa. Okay. And an inlet. As they are connecting, as they are the connecting points to the 4 pipes, they are under more stress than other type of fittings and typically built together tougher than other fittings. So this is constructed or this is manufactured very tough when compared with the different fittings because it goes on very stress because it's not only one pipe which is connected, there are 4 pipes. So very huge impact on this fitting. So that's why it made very tougher when compared with the different fittings because there are 4 points meeting, isn't it? So that's what. So it's not at all recommended, but still they use in some parts. But standards, I don't think so. They'll allow you to do this. Maybe. So the next fitting is over here, the reducer. As you people have studied this, you know this, what is a reducer. This is a kind of fitting, okay, which makes the flow smaller and then reduces it. For example, here is, I can say, half inch of pipe, sorry, a 3 by 4 inches of pipe over here. Here would be half inch. For example, why? Because you can see the shape here, it's changing from here to here. Here is a bigger dia and here is a smaller dia. But what happens? The flow is being reduced, but the pressure increases, isn't it? So just a reducer, just to understand for you people, like example, we don't need that much of pressure over there. So I'll be having is what a reducer, just to reduce the pressure. So I'll be using this kind of fitting just to reduce the flow. Next is what reducer comes in 2 types. People already studied this all because you mostly people are into HVAC and mechanical and electrical graduates. So we know this, we have already studied this. What do you mean by these 2 reducers, concentric and eccentric? Okay, the concentric reducer is something which looks in a kind of shape, and eccentric, if I do reverse of it, that becomes concentric reducer. I'll say you, a concentric reducer is used to join the pipe sections or tube sections on the same axis. The concentric reducer is cone shaped, as you can see over here. and is used where there is a shift in the diameter of the pipes. For example, 1 inch pipe transmits to 3 by 4. So this is 1 inch and this is 3 by 4. So this will be installed in this manner. So this is a concentric reducer. If I upside down this, it becomes eccentric. So eccentric is what? From higher to lower. Let's see now. An eccentric reducer is what? An eccentric reducer is a fitting used in plumbing between two pipes of different diameters. The same thing, because that is why it's called as reducer, because two different diameters. They are used where the diameter of the pipe, this is important, on the upside stream side of the fitting is larger than the downside stream. That means the upside stream, this would be up, the bigger one, and that is eccentric. And this would be smaller. If it is installed in this way, I can say this is eccentric reducer. If it is installed in this manner, from here the bigger to smaller over here, concentric, and from here the bigger to smaller, eccentric. In this manner, it should be vice versa. This should be rotated already online, because this should be at the top. Then you will be getting this. But if I do that, it looks ulta of eccentric. It's the same thing. Okay, concentric, sorry. Now let's move on with the next fitting. That is nothing but a coupling. Now coupling, many people have seen this. It connects two pipes. Okay, like I just now said, now I need a coupling because standard I get a 6 meters of from the manufacturer. So if I'm having a 20 meters or 30 meters of pipe, how will I join this? I need some fittings. So one more fitting comes into here just to join the two pipes over here. That is coupling. It connects two pipes that have the same diameter and are the same type, like same type and all this. It is also used to repair a broken or leaking pipe. For example, and this is how exactly, this is actually a copper. Don't get confused, it will be only in copper. It might be in plastic and all this, also GI also. So this is how exactly a coupling looks like. Coupling is something, a kind of, I can say, compression fitting. You just put and compress these two pipes from my right hand side and left hand side. You just press it, so it have a joint over there and the water goes on. Now example, this will be generally seen to join the pipes, and also it might be used when you are under the maintenance. For example, there is a leak on the floor of mine. For example, I do have a huge kind of piping on the floor, and I got a leak over there, and the pipe got cracked. Something, for example, the water has been leaking over there. So what I need to do is I need to have this in that case, just to fix that. Okay, I need this coupling over there. So again, to rejoin and cut that particular area and to join this, I need this a coupling. It might be different size also. Okay, next is what? Union. Now many people have a confusion that it's almost the same. Coupling and union is mostly and commonly for the pipes joining and all this. Okay, but let's see what difference it has over here. The coupling, first of all, doesn't have any kind of internal or external threads. Very first thing. But union do have. This is a union online, and we'll be having union means a nut over here, and this nut is what used to fix these two pipes. We have seen, I guess, everyone. Let's see this in more in detail. Now unions can have either male or female threads. Now unions can have either male or female threads. They are similar to coupling, okay, but the difference is unions are easy to remove, making them convenient for the maintenance or plan future replacement. Because if I need to do that, I need to cut the pipe. If I need to cut this coupling, because I could not open this because there is no threading, so I need to cut this. Whereas this, I can replace this, as you can see. This is the difference in this. Now a coupling on the other hand is more permanent and needs to be cut out. As I said, a union contains three parts: a nut, this one, male end, this one, and female end. This means what? Inside here the pipe will be going, and here the external thread. So this is male and a nut. This nut is used to join the male and female ends. Got it online? Same kind of thing. We have this thing, but here the difference is of what? A nut and all this, again, just for the pipes to be joined. And this is better because I can replace over there, where in case if I use coupling, I need to cut that because I can't replace that. That is permanent joint, I can say. Next, let's move on with the nipple. Like many people know this nipple, some people have a confusion that we do have nipples only for the extension of the pipe. Okay, and the most important thing, nipples will always be having external threads, that is male threads. Okay, and this is generally used to what? Fix to fittings. Okay, let's see. This is a short fitting that can be made of metal such as copper, brass or steel or CPVC also, so it might be plastic. Instead of connecting two pipes, a nipple connects two fittings, any two fittings. Now it is, if it has a continuous threading, it is closed nipple. They are usually male and comes in varying length. As I said, they are generally male and it might be varying, like if as per your, yeah, this length might be varying, this might be, this length I mean, can be varying. So this is what a nipple, always remember, external threads. That means what? Male threads. Okay, now read it out. Mechanical sleeve. Now this connects two pipes through the use of a screw. Okay, you can see this is screw over here, isn't it? This one and this one. So through the use of a screw or other device it might be. Now this makes the fittings easy to install. The mechanical sieve or coupling is usually made of rubber that is inserted inside a metal jacket. This is a metal jacket and this is what? A rubber thing. Okay. Now stainless steel clamp. I can say this is a stainless steel clamp. This one, the outer body. Now when the clamp is tightened, it compresses the rubber inside to make a tight seal. Following? Generally, I think you can relate this. We do have a small kind of mechanism in India also, especially with our submersible boards and all this. If there is a cut or something in the pipes, where is hard rubber, where we have a black color pipe, generally I'm talking about in India, we do have one kind of union over there. And we do fix it on the both ends. Because of the pressure, it should not come out. We have this kind of mechanism over there. Yes or no? Mechanical seal. Yes, online. Yeah, so the same kind of thing. Now let's move on with next thing, plug and caps. Now many people have a confusion, plug or caps is nothing but a dummy pieces and all this. Yes, okay, it's a dummy piece or something you can say, or it is generally seen at the end, okay, and it should just to close the opening of the line. But it has a huge difference between plug and the cap, because cap is female, plug is male. That means plug has external threads, cap has internal threads. So this is the thing, but same, both are used for what? Closing of the opening of the pipe at the last. That called as dummy piece also. Dummy bhi bolte hain. I think, I don't know what you people say. Dummies bhi bolte. What do you people say? Dummy, right, Anish? No, some people say dummies also, because that's what I'm saying. Okay, so plugs and caps. Plugs and caps are both used to close the pipe openings during inspection and repairs. The main difference is that a plug is male while a cap is female. Most often caps and plugs are threaded, internal and external. Plugs and caps are made up of several materials, including metal, plastic, or rubber, and can be welded, soldered, glued, or thread into the pipe. It depends on the material. Now, what kind of material? So it might be using soldering or welding, whatever. So this is generally CPVC, so no need of this. Just tightening because of the threads and all this. End caps. End caps भी बोलते हैं ना इसको. Okay, so this is what? Can anyone say what is this? Cap or end plug? This is what? Cap. This is? Yes, very good. So now let's move on with adapter. Adapter is a very excellent thing. It can turn anything to anything. It can turn anything to male to female or female to male. Let's see. An adapter connects with the pipes that are not of the same type, because an adapter can be male or female on one end. It can turn a pipe male or female. That means I can use either this way or this way. Here I'm having as a male and here is a female. So I can change anything. Either I can have a pipe I can be making as a female or a male. As internal threads, then it will be going inside. So this would be female and this would be external threads. A bigger dias, whatever it might be. So adapter is something in this manner. So it can turn anything, male into female or female to male. So now why? This will be generally seen in the drainage side, and this is generally the moment I say Y, you can see this Y shaped, and this will be most commonly just to convert the flow to the vertical to the horizontal. For example, here to here in this manner. Okay, generally in rises and all this. Her floor pe dekhenge aap. Okay, this has been connected in this way and okay, this way. Okay, so Y built in the shape of the letter Y. This fitting is made to connect three pipes. Okay, Ys are similar to Ts but the smoother angle reduces the friction and turbulence in the water. This fitting is most commonly used to connect a vertical drain pipe to a horizontal one. In drainage, don't relate now, just a vertical to horizontal. Next, the fittings has been done. Let's proceed with the pipe accessories now. The very first accessories over here, what I do have is a gate valve or isolating valve. So yesterday, as we have discussed this already, so gate valve is something like example, this is a gate valve. You see the cross sectional, I'll be having one small kind of gate in this manner, I can say. This you can relate a gate valve. The moment I rotate this in a 360 degrees, this gate will be slightly lifted up now this way. Again I rotate, this will be slightly more lifted up. Again I rotate, this will be slightly more lifted up. And the moment it lifted up, the water goes in this manner and passes. Okay, and I said because if I try to use this as a regulating valve, it will break the gate. So it can be used as a regulating valve. So gate valve is mostly used for what? The regulation purpose? No, it can't be used. Not for regulation purpose. I said it can't be used. It can't be used for the regulation because it will the gate will be getting damaged if so. So now what I'm saying this, we'll be generally seeing now this gate valve has been replaced by ball valves in modern plumbing now. So we are having ball valves over there. But again, this either you say gate valve or a ball valve. We'll be seeing generally in near the for the complete bathroom, I do have one ball valve nowadays just for the maintenance purpose. Now this has been replaced. Okay, so ball valve. So how it yes, yes, वो ball valve है जो आप बोल रहे हैं उसको close करेंगे ना तो the yes, yes, a kind of I can say a semicircle kind of thing you'll be having in that, a kind of a scoop you can say. Online relating this. Yes, I think many people know this. What is ball valve and angle this gate valve. So now a valve utilizing a gate, usually welded shape that allows fluid flow when the gate is lifted from the seat. Okay, so when it has been lifted 1, 2, 3, 4 times, completely lifted, the free of water goes easily. Gate valve has less resistance to the flow than globe valves because this is a regulating valve and this is not. And should always be used fully open or fully closed. If I use half open or half closed, damage the gate and it needs a replacement then. The a globe valve is generally seen for the very higher flows and HVAC mostly. So a globe valve are different from ball valve. Now many people have confusion, don't confuse. It's not a ball valve, it's a globe valve itself. Now how it will work, I'll show you. Is a type of valve used for regulating flow in a pipeline consisting of a movable disc type element and a stationary ring seat in a general spherical body. Now anyone has seen Swadesh, they can relate this easily. Yes, anyone? They can easily relate this. Yes or no? That scene, I think the moment I said you recalled it. How? There will be some clogging in that, some kind of grass or something. So he just go dip in that and he removes that. And again, he tries to generate electricity. The same kind of thing over here, I'm saying. It's a glow valve over there. He opens it and you know this. The water goes in this manner. The water enters here in this manner. It goes, first of all, it has been stayed over here. The moment I rotate this, as you can see, the stem, the cylindrical sphere body, the moment I rotate, this will be lifting up and up and up, and the more upper, the full, like example, I've opened completely up, the complete, for example, 10 GPM, I will be getting almost the 10 GPM on the other hand side. So this is a regulating valve. That means I can adjust the flow as per my requirement. Example, I have a pressure gauge at the outlet and I need a pressure of 10 psi. If I'm getting 20 psi, I can adjust by pressing this. I mean opening or closing. I mean rotating in clockwise for opening or anti-clockwise for the closing or counterclockwise. So I can, I mean to say is I can regulate the flow as per my requirement. Okay, so this is generally a regulation flow, a regulating valve. Let's look at an angle valve. Yesterday I have said you, the gate valve works on the principal tap, isn't it? Now angle valve works in which thing? No, angle valve works in what? Yesterday I said you, angle. I have said you about the taps. First of all, I said you water taps, underwater taps. We have seen 2 to 3 taps. For faucet, right? Faucet. So this works because in faucet, if you see, we do have a mechanism of angle valve inside. Because generally, now you will be relating this easily, and you can relate with the faucet also. You'll be getting the concept. Now this angle valves will be generally and commonly seen below the laboratories because not air bubbles. That is faucet. I'm talking about an angle valve. Now, angle valve is a valve. Again, it is also a very small valve, but it is a regulating valve. Why? Because I'll say you, this is not directly being connected to the faucet. That's why we do have an angle valve below the laboratories. Because if I do get excess pressure, for example, if it's a G+6 building and I'm using this at the second floor laboratory, I'll be getting a very huge pressure. And I know that, for example, a laboratory demands 8 psi. For example, I'm saying, but if I'm getting 18 psi or 10 psi or 12 psi, what happens online? Anyone? What happens? The fixture will be getting damaged for sure because of excess pressure. And what happens when you compare with angle valve and faucet? That fittings are very expensive. Hmm. This is very, when compared with that, this is reasonable or feasible. We can afford this. That is one time investment kind of thing. Or no, not, I can't say, but it's a matter of like cost saving you're doing this or cost cutting. So what happens? We do have this. So what happens if excess pressure? This will be first getting damaged. After that, what? Because it is blocking the water before entering to the faucet, isn't it? So we'll be adjusting the flow as per I need, and that much is pressure is not at all recommended or not at all required also, because that's so much of pressure if I'm getting, the moment I'm opening faucet, it is flashes out when it hits to the laboratory, and what? My clothes will be getting disturbed, or some other people standing beside me will be getting disturbed, isn't it? So that's why we do have mostly angle valves over there. Same kind of thing faucet has, because of what? Again, inbuilt we have in faucets. Inbuilt. Generally, why we do have this angle valves? Because we don't have faucets. What we do have? Mostly kind of taps. It looks good in interior, but it is not a faucet, because if it is a faucet, then there is no need of angle valve, because inbuilt we do have this. As I said yesterday, because faucet works on principle of angle valve, and the taps gate valve. Now, now let's proceed with the PRV. Now we are entering slowly into the designing concepts or designing steps. Now PRV stands for pressure reducing valve. Now what do you mean by this? The word itself is been saying that this is a valve which is here to reduce the pressure. Now how and where and why and how come the pressure is being increased, or where it should be installed and all this. Let me tell you something about this. Now this valve is a valve. Generally you'll be seeing this in the high-rise buildings first of all, where very big buildings, because in high-rise buildings, for example, I'm having a transfer pump, and I'm having a tank at the 30 floor. Okay, for example, 30 floors means I'll be having all 30 floors. For example, I'm having a tank at 30 floor, and the water is coming from the tank 30, 29 till the first floor. Now, I have thrown one stone. I've dropped one stone from 30 floors of building. Now, just say me the velocity, or just say me the weight or velocity, I can refer you over here. As the stone is getting below and below, the velocity increases or no? Same kind of thing what happens over here. As the water is coming from the 30 floors, it will be coming 30, 29, the pressure is increasing and increasing and increasing and keep on increasing. And I'll be getting so huge pressure that which is not at all recommended as per the standard and codes. And that code is IPC and UPC, which we do follow. Anish, I think you know this. Anish, what is the value where you have a pressure reducing valve? As because you use UPC, 60 psi. And as per IPC, it has been recommended from International Plumbing Code, if you have a pressure in a riser, or okay, because in riser, in water main, that is riser. So in risers only you'll be seeing this. You'll not be seeing inline or within the line or within this floors and all this. You'll not be seeing pressure reducing valve, because where is the main source? From where? Because of the gravity only the pressure will be increasing. So I'm cutting at that moment only. So no doubt I'm maintaining a pressure which is said by the standards or codes, that is as per IPC and UPC. I'll tell you, I'll do an example also right now. Just first of all, let's see how it looks like and where it is been installed. I said you, and why it is installed, because to maintain the pressure in line less than 60 psi or 80 psi, and always remember it is only and only installed in the risers and within a high-rise buildings. Because where I do know this, okay, for sure, don't you people think the water is coming from 30 floors of building? When it reaches to the ground floor, do you people think it crosses to 60 or 80 psi? Will it or no? Yes, online. For sure. It will be like almost 300 psi or something, which is not at all recommended, because we know this as per some table number, as per IPC, we got to know that it is a standard pressure and GPM, which every fixture demands. If I get more than that, the fixture will be getting damaged. Not only fixture, because of excess pressure, what are the things? Leakages will be happening. And for example, I have done a solvent welding and all this, it will leak because of excess pressure, isn't it? So leakages might happen and water hammering will be there. We'll be discussing this later. And what happens? Leakages, water hammering, and excess pressure will damage this reduce the life of the pipes also, because excess pressure. Because if you see the pipe online, as per ASTM or something, they'll be written some PSIs also. Have you observed this online? On any kind of pipe, take any kind of pipe, UPVC, CPVC, on any site of the plumbing. Have you seen? Okay. Or else check in our household only, in the risers, they'll be written something PSI. That is what? That means this pipe can bear this much of pressure only, not more than that. If it is more than that, it will bust. Have a pressure exerted at the bottom formula. What is I'm right now about to find out. The formula is P is equals to H into 0.443 psi. I'll say what is pressure exerted. That you will be one column of water. What you are saying is you will be reading in terms of firefighting in Switzer. Okay, we'll be doing one experimental thing, that is pneumatical formula he'll be dealing with. Okay, and now you can relate, just understand, I am here to what, just to calculate what would be the weight at this pressure, with this pressure at this height, and that is a constant 0.433 psi. I'll be getting, I'm here to right now do that only. Okay, Anish, and one liquid column of height, that is what, 300 mm something, what you studied in firefighting. Okay, don't worry, you will be again seeing this in terms of firefighting. Pneumatical formula, sir will be dealing in detail. Yes, I was saying it is used to reduce the pressure in order to reduce the maintain or the life of the pipe. The valve reduces the pressure of the water that goes through it. That, as Jasna said you, the valve reduces the pressure of the water that goes through it and is used to obtain a regulated and constant value at its outlets. That is a standard value, what I'm going to say you now. It is installed at the water mains, nothing but a riser for the high-rise buildings. It protects the whole installation from problems due to excess pressure, noises in the pipes will occurring, water hammering and splashes, as we have discussed. Now, as per IPC, if you search in IPC, it's been clearly said that 80 psi. If you have an 80 psi, if you have this, there should be one water hammer arrestor. It has been clearly said over there. Now, as per UPC, they believe this: if in the main riser or water main, if the pressure is exceeding more than 60 psi, there should be one pressure reducing valve installed over there. And how it exactly looks like, a kind of spring and all this. So what happens? More pressure, it compresses the spring and all this, it reduces, and the again. Okay. So just first of all see this. There's basement 2. Basement 2, basement 1, ground, first, second and all this. This is what 14 floors over here, as you can see. Then again it's continuing. And from 14, 15 and all this, it goes on to 30 floor. Then on the upper roof and higher roof, I'm having a tank over here. And from this tank, as you can see, there is a water coming down. As you can see, this is directly coming down over here. And I'm having is one PRV. This is spring and all this, isn't it? So water goes in this way, okay, and reduces. Then again, it will be 0 psi from this point. So I'm here to really interested to find, as I got some information now. This, as per IPC and UPC, they have been saying the codes. that if the pressure in the main riser or the main thing over here, water main, if it is exceeds more than 60 or 80 psi, they are been saying that I need one PRV to be installed over there in the water main. Now let me find out what kind of standard they were following over here. Now how I can find out? It's very easy. First of all, let me do one thing. Let me measure this distance, because from here the gravity force will be acting. This is not a gravity force, this is horizontal. In vertical it will be acting. So this water is coming down in this manner. Agree with me online classroom? Okay, right now I'm just about to just learn over here. Okay, this is a PRV location. I clicked it over here. How much the value? Just note it down online. 4017.75. This is in terms of what? Can anyone say? 40170.75. Or yes, very good. Now I have a formula in firefighting. You'll be selecting that pressure exerted at the bottom. That means the pressure here, the pressure over here, because it will be having a pressure, because as the gravity is increasing, the water pressure will be increasing more and more, more and more, more and more, isn't it? So I need to calculate the pressure where I'm getting a pressure of 60 psi or 80 psi. I need to know that. So I do have a formula to calculate this, that is P is equals to H into 0.433 psi, where P is the pressure, where I need to find out, that is nothing but the pressure exerted at the bottom. Okay. And H is what? The height. H is height, and it should be in terms of feet. Write down where H should be in terms of feet. H should be in terms of feet, units. Okay, and 0.433 is constant. 0.433. Okay, and P is what? The pressure exerted at the bottom, because I need to know that only, because if the pressure exerted at the bottom means what? Here I'm saying this point, if it is crossing 60 or 80, then for sure I'll be having is what? 1 PRV over there. So I got a value. Now as per this project they have installed over here. Now let me check what standard they were following. I can prove this now. So I have a value of this 40170.75. Can anyone convert this to feet? How you will be doing this? No. How can you do this? First of all, this is millimeters. 1 meter is how much? 1000. So first of all, divide this and convert this to meters. So 417, I'll say you 1 minute online. 130. Very good. 40170.7502. This is the value. Whole divided by 1000. This is in terms of meters. And 1 meter is equals to 3.28 feet. So I need to divide, multiply, or what? First of all. Very good. So times 3.28. I got this in terms of feet. Now put this in formula. P is equals to 131.76000060 or something like that into 0.433 I'll be getting in terms of PSI. This is 57.05. So what standard they are following online? Yes, online? Yes, very good. UPC. Yes, very good. UPC. So now one more thing I'll say you. As you see over here, this is from the 30 floors. On the 25th floor only I got a 60 psi. There are more 24 floors remaining apart from basements too. So don't you people think we need one more PRV? Yes, for sure. When it is in 6th floor I'm getting this much, I'll be having one more PRV over here. Not only one more, I am having total number of 4 PRVs in the complete project. From here I can say from the 6th floor to the basement, I'm not having any PRV because it's not exceeding more than 60 psi, or 60 is also accepted. They have taken as a safety factor. They might have installed here also, but I think if they were calculating over here, it might be increasing more than 64, 61, 62. That's why they have installed in this floor. Now let's do one more. Shall we online? Be kind of 0. It will be 0 over here because here is 60. It will be blocking this, and the things. Now just see example. I'm having a branch over here. So in order, why we are maintaining this? Because as per this codes, it has been clearly mentioned from the code, if we do have a 60 or 80 psi as per the respective codes, if I maintain this in line, I mean in the main riser, I'll be getting the required amount of, sufficient amount of, I can say, pressure, which performs to work in a very proper manner to all the fixtures. It should not cross more than that, because it is beyond that, because generally and commonly the fixtures, what we see over here, or what if you see over your IPC or UPC, it will be in the range of 8 psi to 20 psi, not more than that. Have anyone checked this, or anyone has any idea? This is the range of all the fixtures of the complete plumbing. It does not require more than 8 to 25. So why I'm fixing the 60? Because I'm not only considering for one floor, I'm considering for the n number of floors. And we know this, that only one floor will not be. Okay, might be this people will be also calling for water, or this people, anyone. But not all the fixtures, but anything, something will be going on in every floor, isn't it? Like washroom, like kitchen area, like shower, different applications it might be in the different floors, isn't it? So to avoid all this, as a standard, they are saying that it should not cross more than 60 or 80 psi. Okay, so here, as you asked, here everything will be zero, because it has reduced the speed. It has stopped that velocity, it has consumed it by means of spring. It tries to compress this. That energy is being converted into this, compressing this or pressing the spring. Okay, that became completely zero. And again, the water is going down. Again, according to me, this might be 60 psi or nearby 60 or exact 60. They have been one more psi. Oh, sorry, PRV. So let's do this also. So for example, I'll be using this again, DI command for the distance. Let's measure from this PRV to this PRV. This is what your question is, right, Mudassir? So let's do this, Mudassir. 42254.30 mm. Convert this to meters, convert this to meters to feet, multiply 6.433. Okay, so I think now, Mudassir, you have cleared your doubt, because it was zero for sure over there. So that's why the moment here is 60, I have one more psi. Still it goes on, Mudassir, because we do have n number of flows now. Because I have seen, according to my experience, if I'm seeing in a logical manner, on every sixth floor, I'm getting almost a 60 psi. That means each floor demands 10 psi of water because of the gravitation pull. It's not standard. Don't fix that. I'm saying that. Okay. So that's what we do have n number of PRVs. It might be 2, 3, 4, 5 as the number of building. That's why I said to you, PRV is mostly seen in the high-rise buildings, because we know this. The moment the more higher building, if I'm having a water coming down straight away from the tank, it will be huge pressure because of gravity pressure. Because if it increases the height, the gravity force also increases, isn't it? It comes with so much of force. I need to block that, because as per the code, it's not been recommended to enter the water more than the 60 psi or 80 psi. The psi is, you know this, units of pressure, not at all recommended. And I said you 8 to 25 psi is the standard, or the fixtures demands, not more than this. 25 is for WC. Yes, it will be always. It's not only PRV. You need to have before this. You need to have for the maintenance purpose. You need to have this. So it will be a station only. I'm just talking about only this thing. This is only PRV. But this installed in this manner only. So this is a station then. No, because we don't. There is no use of what. There is no gravity force acting on it. Do you think so? Because in vertical pipes, isn't it?